Tja, mag iets zachter nog. Maar ik moet even aan die kant instellen dan. Maar zeg als ik niet helemaal de microfoon aan het schreeuwen ben. Als ik niet helemaal de microfoon aan het schreeuwen ben. Als ik niet helemaal ja, je hebt 6,5 uur opgehad. Ja, je hebt 6,5 uur opgehad. Ja, je hebt 6,5 uur opgehad. Hallo. Ta. Nou, als zich komt het goed binnen. Niet te hard. Oké, naar YouTube. Wacht even. Ja, maar staat de audio daar? Oh, je hebt het op de koptelefoon. Ja,
ik luister naar de YouTube stream. Ja, nu komt het binnen.
Oké.
Dus daar is echt wel 10 seconden.
Ja, 10 is minimum.
Nee.
Je gaat niet zo doen, want dan heb je er helemaal niks aan. Het gaat eigenlijk zo, net onder je mond, dat je er overheen spreken. En niet tegen je kin, maar daarom doe ik mijn duim daar, dat wel tegen mijn kin is. En als je hoofd draait, gaat de microfoon mee. Want als je dat niet doet, als je dit doet, dan zoals je hoort, dan horen wij weinig of doet niks. Dus het moet echt zo. En als je niet gewend bent aan hoe je eigen stem hoort, wen dat snel aan. Want als jij niet jezelf hoort, hoort niemand jou.
Ja.
Dus je moet eraan wennen, als je het niet gewend bent. Alsjeblieft.
Dankjewel.
Hoe wil je me aan het scherm verbonden hebben?
Die HDMI.
Helaas, Raspberry Pi, je bent even zonder.
Zal ik jou
Ja.
zetten?
Echt heel erg gaan denken dat ik dit in heb.
Zeg iets.
Ja, kijk eens aan.
Helemaal goed. Dus jij hoeft geen zorgen te maken.
Nee.
Behalve het moet daaraan blijven.
Ja, precies.
Oké? Ja, helemaal goed.
Ik zal eens even kijken of ik even... Oh, hallo. Oh, kijk eens aan.
Volbak.
Ja. Cool, heel erg leuk. Ja. Dat is altijd zo, ja, bij mij. Het komt omdat ik zo'n prachtig hoge resolutiescherm heb op kantoor en dan is alle tekst minuscuul. Ja, ik wil gewoon even zonder topbar. Hahaha. Maar Firefox heeft er even geen zin in. Dat heb ik de laatste tijd vaker. Dan pak ik Chromium erbij. Het is altijd onder Wayland. Dat is altijd, ik heb altijd ruzie met Wayland.
Ik had een nieuwe vraag 2 en hier had ik 2. Nee, 2 headsets.
Het is Chromium.
Headset en een handheld, zeg maar.
Ja, dat is een
Ja, niet zomaar weten. Zullen we toch 2 headsets? Kun je uit?
Daar had ik ook gevraagd. Ik had voor deze zaal 2 gevraagd en ik had voor de nieuwe vraag 2 gevraagd.
Gaan we even kijken wat het
Ja, dan kun je eentje van hierin regelen, dat gaat er niet. Zij hebben hier natuurlijk ook gewoon die headsets als je die kunt inregelen.
Er waren 2 in die kamer. Wij hebben 1 voor deze kamer en 1 voor die kamer.
Ja, nee, dat snap ik. Maar ik had gevraagd hier 2, daar 1, daar 2. Dus 5 in totaal.
Dus ik heb die kan er niet uithalen. Dan moeten we het uit de andere zaal.
En ik heb nu ook in nieuwe vraag 2 en hier 2 nodig. En volgens mij is dat ook de enige keer vandaag. De 50 lijkt me ook.
Ja,
Kijk maar.
Prachtige foto van Norman in een kast. Dat is toch Norman?
Kijk maar.
Dat is Norman. Ja. Ja, ik zet hem even zo groot. Dan pak ik ook altijd. Ja. Kijk, en als je dan volgende gaat, dan ga je automatisch de vorige ook zien. Ja. Ik ga nog even gauw naar het toilet. Ik ga nog even gauw langs het toilet. Ja, kun je mij eventjes... dankjewel. Ik ga nog even gauw het toilet.
Deze veilig neerleggen of
Ja, dat ging ik gewoon.
Marcel, weet jij dat?
Ik heb deze ook niet gezet. Ik weet het niet. Is dat... Dat is ook...
1, 2, 2, 2.
Kijk, heb je een broekzak?
Oké, hey, there we go.
Stel dat je straks je handheld wil gebruiken, dan moet je echt deze uitzetten fysiek, dan zit je op dezelfde frequentie. Dat stoort elkaar.
Welke?
Ja, de handheld. Ik heb daar langs nog een handheld
Bla,
liggen.
bla, bla,
Als je
bla,
het tegelijk wil,
bla, bla.
wil doen, dan...
Bla.
Eigenlijk wel. Want
Hallo.
dan zou die...
Kom je hier vaker? Zo, nou ja, ik meestal zo'n 2 keer per jaar. Ja, kijk, alle telefoons op stil.
Ja, dat sowieso.
Even op niet storen, voordat er andere mensen...
Volgens mij heb ik de meeste stickers, dus ik heb dat laptop maar neergezet.
Wat zeg je dat?
Ik heb volgens mij de meeste stickers van ons beiden, dus ik heb mijn laptop.
Maar we moeten die van jou echt uitzetten.
Oké.
Zodat die... Want dit gebruikt dezelfde frequentie als die.
Ja.
Dus we moeten jou heel even...
Dan moet je deze weer uitdrukken aan die kant.
Ja. Ik zou kijken wie die kamervoorzitter is. Dat weet ik nog niet.
Oh, oké. Zeggen hier 2 nu?
Ja, maar ze moeten echt...
Ja, maar
bij het voorstel, hij begint, moet hij fysiek uitleggen, ze zetten ze niet weer aan.
Dat is gewoon inrukken of
Nee.
En hiernaast zal er ook 2 headsets dan nu.
die zaal heeft maar 1 nodig.
1 headset. Oké.
Onze
En daar staan
2,
we.
die hebben we daar.
Die hebben we daar. Oké, dit was een spare.
Dus ja, waarschijnlijk als er maar 1 spreker is, zullen wij dit gewoon gebruiken.
Ja, om te wisselen.
Ja.
En dit is dan indruk of indruk houden even?
Ja, je geeft het zelf aan.
Dus die in de programma.
Wel even indruk houden, ja.
Dat is dubbele frequentie.
Ja, de interferentie.
Ik zorg dat het goed komt.
Super, dankjewel.
Nee.
Ziet er goed uit.
Ja.
Hoe was het je nou gelukt?
Het was de HDMI-kabel.
Die heb je veranderd en toen...
Geen probleem. Het was echt die HDMI-kabel.
Het was maar... Ik was er toen mee aan het wonderen. Ik veranderde iets, hè? Ja.
Ik probeerde alle andere dingen en niks helpen.
Ja.
Dus uiteindelijk was de enige tijd maar ook het probleem. En nieuwe HDMI-kabel. Alles kwam binnen, gelijk.
Ik zit daar best wel een beetje losjes in, hè? Ik had daar zoiets van.
Ja, nee. Het lag aan de kabel.
Ja, dan.
Ja.
Ja. Nou,
Op zich is dat wel prima.
Nou, gelukkig.
Ja, we hebben een beetje gedoe mee. Deze.
Ja, dat lijkt me een goed idee. Ja. Ja. Ik ga trouwens even een beetje die kant op en anders sta ik echt totaal in de beamer.
Okay, Debbie gave me the thumbs up, so we're ready to go. So we all need to move away from the big tech cloud providers, right? Google, etc. That's not done anymore, and we need to, make use of more diverse hosters, etc. And so Max and David have done this for years already, so they have lots of experience, and they are from the University of Groningen, and they are going to tell us all about how they are doing it. Please welcome Max and David.
So welcome all. Welcome to From Complexity to Simplicity, our cloud infrastructure redesign. I'm David. I'm the architect of our Cloud 4 project at the University of Groningen at the High Performance Computing team. And I'm here together with Max. And we are going to talk to you about our new cloud infrastructure and how we've changed things. We are from the team HPC, the High Performance Computing team. Basically, we make computers go fast. What we do is we provide all sorts of services for science, for education, and for basically anyone with an interesting project who asks. And everything we do is all built, it's run, it's operated all by ourselves, by in-house teams with us at University of Groningen in the HPC team. Who do we do that for? A good example, let's start really big. Like we have one of the projects we contribute to is the Euclid satellite from ESA. We work with the Kaptein Institute on this, and we help the ESA map the known universe. And also we do it for the very small, like we work with the Genomics Coordination Center at the University Medical Hospital in Groningen, and they unravel the human genome. So from the very big to the very small, we do all sorts of stuff. But the thing we're most proud of, I think, is that we work with over 3,000 at this point, individual researchers, including you if you collaborate with the university. We've had 1,306 publications, and that's just the ones that we know are actively attributed back to us. I'm sure there's also sort of indirect ways. So let's talk about what we have today, where we're coming from. We run a big supercomputing environment called Hubrock. It has 20,256 CPU cores. If you're like me, you think that's a really nice round number. That's distributed over 204 machines. There's 60 GPUs in there, the big kind, and there's about 13 petabytes of storage in there. And we also offer 1,250 plus and growing every day software packages for researchers to use in their projects. Underlying that, we have two clouds. We're in two data centers. This is one of our data centers, the Koenraad Bron Center, the newest one. And those, we operate really quite big clouds. One of them is focused on providing bare metal to customers, and one of them is providing more to the virtualization workloads. If you look at our service, it's basically like this. We have Hubrock. This is a Lego house already assembled in a way that we think agree with us on that one. So we provide all the individual bricks for them as well. The same things that we use to build Hubrock, we provide to our clients, and they can build it wherever platform they require, in whatever setup they need.
And that's our infrastructure as a service. That's the idea. Today we use a couple of technologies for infrastructure as a service. We use OpenStack as our cloud orchestration system that provides just QEMU KVM virtual machines to clients. It does bare metal provisioning for us. We also have virtual networking through Open vSwitch. And we have centralized storage systems as well. We use Ceph mostly for block storage at the moment. And we have several Lustre file systems for large parallel operations on multiple machines. In a big graph, or a big chart, provides all of the things that you might need to build your own platform. And today we're going to focus on this a little bit in here, the core of our infrastructure as a service environment, and how we automate and construct that from base parts. I talked about OpenStack. OpenStack, what it is it's basically a way to pool your resources. We have a whole bunch of machines. Those machines have CPUs in them, they have memory. They also have all sorts of network connections all over the place. And of course, there's a central storage system, and it aggregates all those resources into 3 individual neat little pools. And whatever the users want, they can dip out of in whatever proportion they require. Seems nice, right? It's really nice. OpenStack's actually pretty good, but this is also OpenStack. We don't really need all this. We don't use most of this. And this is also where our complexity problems arise, because when I remove everything we don't actually need from OpenStack, we end up in actually in there. Most of these we don't use. But it's nice. It gives us one API, many different clients. People can use a nice little dashboard if they're clicky people. They can use just in their shell whatever command they require. And if they want to automate, they can use a Python client, and they can interact with it that way. And they can pick and choose around whichever they want. And then they can build their own little virtual data center, build their own little networks, build routers, build machines connected to networks. They can assign their own subnets, they can do whatever they want, and then we will provide whatever is required from the outside. Basically like any other cloud you would use out there from the hyperscalers do. And we provide similar services. And how do we deploy that? We use the official OpenStack deployment tooling. There's lots of stuff out there. There's Kola. Kola puts OpenStack in containers. Then there's Kola Ansible, which deploys those containers across lots of machines. And then there's Koyobi, which orchestrates that. That deploys one cloud, and that cloud then configures another cloud below that cloud. And then for Ceph, we use Ceph ADM, which is a deployment tool which deploys Ceph in containers. And then Koyobi also orchestrates all of that. And if you're overwhelmed at this point, so were we. This is incredibly complex. There's lots of interconnected moving parts all over the place. This makes maintenance evolution for us extremely labor intensive. We spend a lot of time figuring out just how this actually works. And we're dependent on that external deployment system, which doesn't probably have, but actually has very different priorities than we do, because it needs to work for everyone. And we are not everyone. And it contains lots of stuff that we don't actually use, but that is still in the chain. So if something we don't use does break, then that does also break the things that we do need, which is not optimal. We arrived at this situation by making the right choice probably every time. I always start with the assumption that along the way, well, however you got to the current situation, it's probably because people made intelligent, informed decisions the best they could at that given moment. But the way systems grow organically does not necessarily lead to the most optimal setup. Sometimes you need to take a step back and maybe look how you can improve things, make some choices that are different. So what do we want from that? We want to make maintenance easier for ourselves. That is very important to us. Stability and reliability are really important quality aspects for us. But we are also engineers, and we like having quiet, peaceful lives and building fun stuff instead of waking up in the middle of the night when something breaks. We want to determine for ourselves what we have. We don't want other people determining you have to use this software stack, you have to use these parts. If you want this, then you need to configure it this and this way. No, we want as little infrastructure as possible, deployed as simply as possible, and we should do that. And of course, we want independence. We want to determine ourselves what we think is important. And that is the core of being independent. We decide, we are in the driver's seat. We decide where are we going? Where are we going now? Is this good? Do we still need this? Etc., etc. So, where do we go from here? Max?
Yeah. Now it's up to me. Where do we go from here? First, why do we do this to ourselves? We run this OpenStack cloud. You can have some other options. You can look at, for example, VMware. You can have an external party host it for you, and then they will run your open cloud. You don't need to touch anything, but they'll do it for you. Or you can just toss it over the fence to Azure or Amazon or what have you. The things you quickly run into that they all share is that you get a lot of stuff that you don't need if you let somebody else run your OpenStack. They will have all those parts that they've just described, and we don't want that. If anybody ever looked at the services pane of Amazon, there's quite some stuff in there. The clusters that we run, we really run them. Habrok is churning out calculations all day, every day. Once you start actually using the compute on a public cloud, you start really paying for it. Also, you lock yourself to a specific vendor, you might lock yourself to a specific party. Recently, this has shown to be sometimes suboptimal if you're beholden to a VMware which decides that, well, we don't really want you as a customer anymore, and we might just sue you a little bit if you want to update. Or if your vendor is located in a country that decides to experiment with spicy democracy, you're locked in. You can't just pick your stuff up and go. And currently, we've locked ourselves into OpenStack, yes, but this is an open source platform. If we don't like the direction in which they are going, we can fork it. We have control. This is a big part. We have autonomy, or we want more autonomy. And if you give out the keys to the kingdom to another party, you lose all autonomy. Also, tendering isn't fun. So, new approach. We will build our own stack, our own distro of OpenStack. We will build this with not Blackjack and other things, but with Salt and with Python, because we like Salt and Python. We are going to be ruthless about you ain't gonna need it, as David showed. We only use a little bit of the stuff that's offered, so we only want that little bit of stuff. Our core principle here is that everything should be made as simple as possible, but not simpler. We're not going to hide things away to make them look simple. We want them to be simple-ish, as far as possible. We're abstracting things away doesn't make them simpler, it just hides the complexity that is there. So our goals is to maintain the knowledge that we have within the RUG, within the CIT, and evolve that knowledge, to grow our knowledge, to offer our users, our researchers and other customers a stable and predictable environment. They want their stuff to be up. They run a lot of calculations. Some of these runs for days and days and days. They don't want disruptions there because that costs them a lot of time, and they don't like that. And we want to optimize for lifecycle work and not deployment work, and that's something that David will dig into a little bit later on. Okay, so those are our goals. How will we manage that? Infrastructure as code is a must. We currently already do this, but with a couple of layers in between. But it is a must. If you're managing a couple of hundred machines, you're not going to do that by hand, clicking in an interface or just manually logging into a server to poke a little bit at the configuration. So infrastructure as code, we heavily prefer open source technologies because this is really, 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 really important if you want to have your autonomy, if you want to have control, because you cannot avoid all closed source things. The servers have their ILO things or their iDRAC things, and that's closed source. Switches will have a proprietary blob sitting on top of a Linux switch. We can't work around that. We're fine with that, but the things that we do, the glue in between, that should be as open as possible. And we want to work with the garage door open, so our new setup is in a public Git repo. You can all check it in, you can look at our fumblings and successes, hopefully. We want to work with the garage door open. We're a university, we are an institute of research and education, and we want to build that out. So, what's next? Well, let's take it simple. We're just going to build a new platform to replace those two big platforms that David just showed. Nothing too ambitious. We're calling it Cloud 4. And how do you start one like that? You start with some strong design principles.
Yes. We define 4 design principles. I talk about these frequently. If you ever follow lectures at the University of Groningen, and I give one, you will have heard these ones. But the core idea behind how we build things is we build an opinionated framework first. Cloud 4 is our framework. It is what we build. It is what we build to build our clouds with. So build our tool set. And then we use that tool set, which is opinionated to how we think stuff should work, and then we deploy our cloud with that. Because we believe that one size probably just fits one, right? This will work for us, and if someone else likes it, then they are free to use it and do with it what they want. We are a university, but it's built for us, and it should work for us. And we like solving problems first. We're not going to use that fancy new mega cool reverse proxy that just came out. We want to solve our problems, and we want to probably do it as boringly as possible. We've all seen servers chugging along for 10 years without any issues. We want to build stuff like that, right? Not sports cars, Dacias, right? I drive a Dacia. And we want to minimize complexity. If we don't need it, we don't include it. And if we can solve a problem simply, we solve it simply. And once things become more complicated, we can then look at how to improve the code. And we apply, in this framework, a very loosely coupled setup. We have our Cloud 4 framework. That's kind of like a library-based layer that we use to deploy our stuff. And we set up a Ceph cluster that does our storage for us, an OpenStack cluster that does the aggregation and providing stuff as a pane of glass to our users. And then we have a bunch of supporting services like monitoring, automation, proxying, databases, all that sort of stuff. And we make these as loosely coupled as we can. These share credentials, not code. That's kind of the idea. And that way we can have a Cloud 4 framework deployed environment where we only use the monitoring part. Or say we want to set up a storage system for a client and they don't need virtualization. We just grab a Ceph cluster, maybe some of the supporting services to make that work for us, or monitoring it a little. And that works. So we can have that sort of flexibility. And it also means that if one of these breaks, it doesn't break the other ones. I do commit breaking code sometimes, and that it's nice if it doesn't break other parts. Our second principle, focusing on the life cycle. This is very important. It's an older case study, but it's a really good one, and it's been repeated a couple times. 79% of costs over the lifetimes of a system will be your life cycle cost. This is fixing bugs, changing stuff so it fits within the world it exists in, because the context will change for your system, so you need to adapt to it. And it means pure maintenance, screwing stuff into servers, replacing disks. This is the most expensive part of running any operation, and it's the same way for us. So this means that maintenance is much more important than deployment. This is a very important point for us. We want to build some stuff that is very easy to maintain, even if it takes a little bit more work to get it running at the first time. That's fine for us, because all of our time will be spent on maintaining it. And of course, all normal work, this is site reliability engineering staple, all normal work should be automated or automatable. And what normal means will change over time as your context changes and what your client's demand of you changes. But it should be possible to automate your work. This is one we stole from the Zen of Python, which is beautiful. If you have a Python REPL open, you can run import this and read the entire Zen of Python. It's a recommendation. But the important one for us is that there should be one, and preferably only one, obvious way to do stuff. Code is written for the reader. So if we write code, it should indicate how it works, and also how you, if you change it, how you should change it. Practically what that means is that our code structure should encourage the correct behavior of whoever changes the code. We do our config management declaratively. We describe our desired end result, and then our code base, whatever we use for that, should figure out the delta and then apply that for us. Usually that works, but it's nice because you have a very nice setup of knowing exactly what your end result should look like, as opposed to what the steps are to getting there. And we apply that the exception is the rule. We do not repeat ourselves as we can, and I can practically show this with a code example. Yes, there is code in this presentation. We use something, it's part of Zaal called the pillar, it stores secrets. But the idea is that we have this global set of defaults, and we override those defaults in increasing specificity. So we have what we think are sane defaults, and then we only change what differs in a different environment. For example, we think that all Ceph machines should have a certain version of Ceph, but if we go into a certain environment with a certain domain name, there should be a different Ceph version there. Or a specific host should have a little bit of a different network configuration. We can do it that way. And this is just taking a Python dictionary and updating and updating and updating and updating. It's not very complicated, and that's how it works. And this code is publicly available if you want to look at it in detail. As I said, everything should be as simple as possible. No simpler. If you try to hide complexity from yourself by importing something from somewhere else, then that complexity has not disappeared. You simply offloaded it to someone else, which might be the right decision, but not necessarily always, because it does put the onus on you to actually understand what's happening. Because we always take the approach that we are the only responsible people for how our thing operates. So if we import something from someone else, or we buy something to somewhere else, we are the ones that are responsible for how good our system works. We do not point to vendors or library maintainers. We chose this library, we chose this component, so we are responsible. And of course we apply, you ain't gonna need it, to keep complexity in check, and that practically means just delete code, delete code, delete code, delete code. If I've had a good day, I will have written less code than I have deleted from the code base. Sometimes stuff just doesn't need to be in there anymore. It happens. So we need to get rid of it. And if it turns out we did need it, we'll just reintroduce it again later on. It's fine. That way we do at least test that our code is in there, and we don't end up in a situation where there's some bit of code that's lying around there that nobody desires to touch anymore because it might destroy the universe in some way. So those are the 4 principles for us. Building an opinion in the framework, and then building our platform on top of that framework. Then we focus on the lifecycle, not on the deployment. We have one way of doing things, and that should be the obvious one. And we prefer simple over complex, but if complexity is required, complicated is worse. So keep it succinct and well understandable. Max.
Well,
Glad you asked. Time for a table. Wow. When we look at the differences between the current system we have and the thing that we have planned and are working on, as we've already mentioned, the old system has to work for everyone. This is built from a set that is generic in setup, and you can build this kind of cloud, you can build that kind of cloud, you can build all kinds of clouds, which is wonderful and useful, but not to us. We don't want a generic cloud, we want our cloud. In the current system, it is a lot of static configurations, so machines are, for example, mentioned by which MAC address should get which IP address to build the networking layer. There's a whole lot of configuration in that way, and in the new system we try to offload more to dynamic configuration. So a machine might be added to the cluster, and we want to do as little as possible to get that machine online into the cluster. So we want it actually to, well, have it pixie boot itself and then mention itself to the salt master and say, hey, I'm here, and it gets configured and we don't need to lift a finger. That's wonderful, that's what we want. The old system had just shy of 300,000 lines of code. A lot of that makes up things that we end up not using, as David showed in the beginning. The new system, therefore, uses quite a lot less. It's well, a little more than 5,500. Recently, they did some pruning. It was even less than that. But either way, it's massive downscaling of lines of code. 5,000 lines of code is still something you don't bang out in an afternoon, but it is something that you can attempt to reason about, attempt to have a mental model of, and 300,000 is not going to happen. In those 300,000 lines, there's a lot of tech debt. There's a lot of older decisions that were the right decisions at that time, but might not be the right decisions anymore. We want less code. We also want it to be easier to add functionality and to grow this framework, this platform that we're building. And because all of those reasons, it means that the old system requires a big bang upgrade. This means that we need to bring the whole cluster down, which is a process of days, because sometimes there will be calculations running for like 10 days. We need to wait for those to finish. We cannot start new calculations. We have to wait for 10 days, then we have to flush the whole thing, bring the whole thing down, do the upgrade, pray that it works, bring the thing back up, and then people can start using it again. So you're looking at an actual downtime of days and a run up to that of even more days. We want to have a system where we can update bits and pieces with the rest of the stuff just humming along. Sometimes you will need to bring things down, but we want to minimize the amount of downtime that we need for upgrades. Yes, so many containers. As David mentioned, Cola does everything in containers. They do have their uses, but they also add at least one layer of complexity, so Cloud 4 will have just no containers, not even SAF ADM, it will just have no containers at all. The templating system is also a lot of fun. There's templates to build configurations, and there's also templates that build parts of other templates. So you'll have a bit of YAML looking text, but it's actually not YAML, it's cosplaying as YAML, and it might conditionally be included in some other bit of YAML, and it's a nightmare to reason about. If something goes wrong, you'll have to dig and oh, this one references that one, oh, that wasn't. It's a nightmare to work in if something goes wrong. We will still use templating, of course, but it will be a simple template, and if if we start seeing a lot of conditionality cropping up, or we start seeing Ginger being used as a programming language, well, you can just say, well, no, we're not going to do this in a template, we're just going to write a neat little Python module for it. On the old system, the control plane also runs the network. The control plane is the bit of OpenStack that decides, well, you wanted a VM, fine, we're going to put that on that hypervisor, or we're going to shuffle you to that bare metal node. And the networking is all the virtual networking bits, which means that all those nodes can talk to each other. Those are all on the same couple of machines, which means that if the control plane goes down, because you need to upgrade it, for example, your entire networking stack goes down. This is not ideal. In the new setup, we therefore keep these two strictly apart, so we can update the control plane, because once things are running, you can actually pull down the control plane, update, and everything will keep humming along just nicely. Keep things separate, keep things updatable. The current system is dependent on a lot of VLANs, because machines will have separate connections to a management network and a provisioning network and a storage network, and oh, we have another storage network, and look at that, we have yet another storage network. In the new system, we're going to lean more on routing, because using VLANs is well, it works, but it means that you always have to keep in mind, okay, am I on the right VLAN? Is my switch configured to put all these VLANs to the right ports? We just want to use routing. We think that's much easier. Also, this will work with a IPv6 only internally, a setup on the new cloud, which means that we have quite a bit of IP addresses, so we won't run out that soon. We had a /48 for the whole endeavor, so that should give us some wiggle room. Of course, there will be IPv4 connectivity for the people that use it. That will happen at the edge of a cloud, and then internally everything will be routed over IPv6. Yes. So, fine, we'll build it, and then people need to be moved to it. How do we do that? Well, we start by building a new mini cloud in the new setup using the new framework next to the old one. The old one will be untouched, it will just keep running, nothing changes there. We build the new one, build the control planes, run the setup, make sure that it works, and then we start clearing out, for example, hypervisor on the old cloud, move it over. And then we can add machines and racks one by one and gradually increase the capacity on the new cloud, and then start moving people over. There will be early adopters who will say, ooh, shiny, and they will jump at the first opportunity, and they will test for us. This is wonderful. I mean, you can do all kinds of planning, but nothing beats having something do something completely weird to your system that you didn't think of. Then the bulk will be the pragmatic people. Okay, this new cloud offers more functionality than the old cloud. This is something that I want to do, and I cannot do it in the old cloud, but the new one I can, or it runs faster, it runs better, it runs more stable. I want to move, please. And then at the end, you'll have a couple of people who say, but things work, I don't want to touch them, effort, but at some point you just have to, of course, so they'll be cut over when the old cloud is gradually consumed by the new one and will be EOL'd. And that's that. Well, simple, right? Is there a catch? Well, yes, there is. It turns out that building and designing a cloud like this is quite a bit of work. It's a lot of effort. David started this project a year and a half ago. It's not in production. We are in a testing phase.
We're in beta, yeah.
Yeah, we're in beta, so it's absolutely moving along. It's not for lack of effort, but it's a lot of work. The biggest part of that work is figuring out, okay, what exactly do we need? Because we don't want to build a cloud for the sake of building a new cloud, as cool as we think it is, but it's something that our users must be happy to use, that it must be useful for them. So we need to figure out, what do you do? What do you use this cloud for? How do you use it? What requirements do you have? Do you need things to be secure, or do you not care about that? Do you need things to be this fast, or this fast, or this fast? There's also the bit where we need to understand our legacy, because this bit of code that we have, like David already mentioned, it got there for a reason. In the years where it has been running and servicing us very well, it has grown because of a certain reason, and we need to figure out that reason and make sure that whatever reason that is it still valid? Then we need to incorporate that in our new cloud. So this is a lot of trial and error, and a bit of software archaeology. So, next to that, we still have these two existing clouds, and we need to keep them running, because people are using them. We can't tear them down. We can't say, oh, we're not going to work on this old thing anymore. We're only going to build on the new shiny. No, the new shiny will have to be built right next to the old one. And it also means that we need to have frequent talks with the people who are going to be our early adopters, but also our bulk users, about this is the thing that we're building, this is the thing that we're thinking about. Do you have input? Do you have opinions? We have to keep them in the loop. And they should have a clear migration path, because at some point they will have to move their stuff from the old cloud to the new. And we need to guide them in that, help them with that. So that's a lot of work. So we're not done yet. But we're making nice headway.
Yeah.
David.
Yeah. So I'll just sum stuff up for you just at the end here. What we've talked about today is actually, I think, a good takeaway is that the way systems grow organically does not lead to the most optimal setup. There's no point feeling bad about the way things are. People probably made the right choice making them that way. But the end result might be suboptimal. So reassess, take a look at what you actually need, and move on from there. We looked at the principles, we built an opinionated framework, and we use that to build our clouds. We have a couple of those running now. We focused on the life cycle because that's the expensive part, that's the labor-intensive part, and that's also the part that wakes you up in the middle of the night. And we have one way of doing things, should be the most intuitive option of doing things that helps in the evolving of the code and keeps the code base relatively small. Everybody knows that, especially considering the last one, if you've ever written code that you know that you can bang out a whole lot of code in an afternoon and have it be spaghetti, and you can also spend a whole lot of time on a very small bit of code having it be very nice. So size is not necessarily better. Keeping it simple is essential, but if it needs to be complex, have it be complex, but don't make it too complicated. And of course, one final very important thing, it does run Doom. Thank you. Want to see the code? You can. It's on there. It works for us, just for us, and it's really boring. Enjoy it. Haha.
Hello, hello. Yes. Okay. I think for the recording, it's good if questions are spoken in the mic. Is that right, Nick? Yes. Okay.
Very interesting. I can relate to a lot of your struggles from own experience. How do you deal with the fact that if you're building something new that has maybe not a one-on-one comparability in features, and education for the people that need to use the new platform to be aware of what it can do and how it works, because otherwise they will be requesting the same features from the old platform for the new platform and are not aware that probably there is a different solution that's possible on the new platform.
Yeah, that's a very good question, and it's something we actually struggle with a lot. At first it started actually with just technical evangelizing, me having to sit at people's desks and convincing them that the things they were doing necessarily were not the best things. And that is always hard. And then you convince people, and then the technical side starts rolling. But then you've got a lot of customers around, and then you've got management, you've got tens of thousands of stakeholders, it feels like sometimes. But in reality, once you convince them of things, you keep them in the loop as much as you can, you find people that will also believe in your idea and your vision, and you present it to them, and you'll have them help you in convincing them, because nobody will convince a client of how good the new stuff is like another one of your clients. You need to find your allies and build a coalition. It's very political in that sense. It's all about people.
Thank you.
Yeah.
Hello, thanks. Very interesting talk. At the risk of stating the obvious, there's a lot of talk, obviously, about European clouds and being autonomous, etc. I know the University of Nijmegen is facing more or less the same challenges. Are there any initiatives to extend your work to other universities and maybe even cooperate between universities and get some funding to centralize efforts and profit from all universities?
Yeah, we have people over a lot of the time. This is also an open invitation to anyone who wants to take the effort to go to Groningen and wants to check stuff out. We work with the door open, so everyone is always welcome to look. And we have guests from all over the place, from government, from other institutions within Europe, other universities. But this is actually one of our first big pushes in getting this out into the world, and we intend to scream from the rooftops what we're doing and allow everybody to criticize or use or whatever they want. So I would invite anyone who wants to come over.
Max, if you want to add anything, bring you the mic. Okay. First.
Hi, thanks for a very interesting presentation. You talked about the old system having VLANs versus new system having edge routing and IPv6 internally. Can you expand a bit on that? Because I don't quite understand what the difference is here.
Yeah, we have a whole lot of... we had a lot of issues with the fact that everything becomes, at some point, one gigantic layer 2 domain. And because we offer software-defined networking, in theory, customers could just pull loops whenever they wanted. It's not something we like. We are guilty of doing it ourselves sometimes. But overall, we do like sort of the scalability and reliability of edge routing. Edge routing also, because our traffic is mostly east-west across the racks, it can be quite optimal. And the choice to do IPv6 internally is also to encourage behaviors from people, because eventually it's all about people. And the fact that you have that many IPv6 addresses doesn't force people to not remember IPv4 addresses and actually configure a decent DNS infrastructure. So we try to be the change we want to see in the world in that sense. And it does scale a little better. I've had talks with this. It's also a bit of an ideological crusade. IPv6 was the future when I was in primary school. So I think it's about time.
Yeah, so you say I work with the garage door open.
Yeah.
And also you say, well, we actually had to spend a lot of effort, like 1.5 years, and we are still not done yet. And you're also having people over who are interested in your project. So my question is, what are your ideas on like cooperation in the future? Will it be your project, your code, and will it be like, say, you only publish and you don't take back? Or are you thinking about, like, maybe we can not make something just for us, but for people who are very similar to us, and then become an open source project? Because I mean, that's the big difference, right? You're just sharing what you're doing, but you're not running it as an open project.
We would absolutely be happy to collaborate, to expand, to help people who have the same ideas, opinions, and needs as we do. That would be absolutely fantastic to us. We champion a couple of open source things. We're founders of the European EASY project, the European Scientific Software Installation Stack. We host Statum Zero of that. We do a lot of open source work, and we are really happy if someone wants to collaborate with us. Maybe try running it themselves. Worst case scenario, we'll wheel a cart into your office with a bunch of machines in there and you can play around with it. We love working with other people, which is also why we're here, right? So it's an open invitation. Come to Groningen, we have really decent coffee. This has saved us so many trips. Yes, absolutely.
Very good.
Oh, yeah.
When you started the new system, did you also look at the Apache Cloud Stack, or just that? Can you elaborate on your choice?
Yeah, we have a lot of institutional knowledge on OpenStack, so that's a very eventually people at the end are also the most important part of your decision matrix. I'm not excluding CloudStack from Cloud 5. We've already had talks about that. It might not be OpenStack next time, but there's also the trap of you can fall into of changing too many things at the same time. So let's do what we have now, but cleanly, nicely, better, and then let's see where we go from there. But yeah, CloudStack, I've heard good things. So.
Yeah. Another question. You showed those 3 modules, and you said that you could swap those for others. So would it be possible to run this with a completely different storage stack, for instance, NetApps?
In theory, yes. We're currently on the process of also implementing Lustre, for example, as a file system storage into the Cloud 4 stack. So you could run Ceph or Lustre or both. But the whole idea is that we can add more parts so long as they are as loosely coupled as possible. That is the core. So people can just pick and choose, but it's not like it becomes one big chain where one thing breaking will break everything. That's the core philosophy. So adding more, yes. If you actually look on our repository, you'll find, I think at least at this point, 10 or 12 different software modules. Yeah.
Yes.
You mentioned abstraction hiding complexity is not a good solution. Is that specific to your circumstance, where you try to reduce the code, or can you elaborate on why that is not a good solution?
There is, of course, the law of leaky abstractions that even if you abstract a lot of stuff in your infrastructure away, eventually some file needs to be written, some systemd unit needs to be started or changed or altered. And as long as the abstraction helps you to manage that, that's nice. But as soon as it becomes an obstacle where you say, I want to have this running there, or this file should be written there, or this should be there, and you have to actually go through some sort of lasagna-shaped labyrinth to figure out how that works, then it works against you. So it's very circumstantial. But in our case, we have found that given the fact that we use mostly a fork of a public thing, which partially forked, not entirely, we get all the stuff that other hardware vendors put in, other people put in, and then we have to navigate around those parts. It becomes really hard to differentiate between what do we want and what does the system demand of us.
All right. I believe we one more. Okay, short one.
Why stick with salt?
We have decided on salt as our least worst option. No, it's actually, I like salt, but it is also a thing where you can really easily not see the forest for the trees. But we have a local community around it in Groningen, so that helps. We have a lot of people. If I need help, I can call someone who has been to many saltcons and invented stuff. And actually, from the research side, because we are part of a research domain, we may look at inventing something new at some point. That's also an option for us. But it allows us a bunch of. It allows us to solve a bunch of complex problems that Ansible is too simple for in certain ways. Ansible is really awesomely simple. I like it a lot until you need a certain level of complexity, and then you need to have 7 stages and pre-compile everything, and your gathering facts takes, our current gathering, we could use Ansible right now, current gathering facts takes more than an hour. Yes. And then it might break after that hour and spit out a single line 50,000 character error. So this happens. And we build like our own Python library atop of Salt as much as we can. So that helps us solve stuff.
Okay, thank you. That was amazing.
Thank you.
Sorry, I lost a little bit track of time, but there are a few minutes left to switch room. And if you don't, there's more diversity here with a alternative web browser, the Ladybird. Okay, welcome everybody. We are 3 minutes past the starting time, but that's fine. We will give Jelle 45 minutes still. So more diversity is important along the whole stack, not we just had a talk about different cloud solution, which was fantastic. And now Jelle will take us all the way up the stack to the browser world, the application world, and talk about Ladybird, alternative browser.
Well, thank you.
The floor is yours.
Well, hello everyone. Ja, dit is applaus. So, yeah, I hope you're all as excited as I am for the web. Not because of the state it's been in the last couple of years, or decades even, but the way it's going right now, because a lot of things are happening, and I'm very proud to be a part of a new generation. And that's Ladybird. So, I'm Jelle Rijmakers. I'm the COO of the Ladybird Browser Initiative, which is a 501c3 non-profit. We're based in California. No one of the team actually lives there. We are situated all over the world. And if you'd like to know more, or if you would like to contact me, you can find me on X. You can contact me by email. But I think we first need to talk about why do we need to create a new browser. Whenever I talk to people about what we're doing, the first question is always, why? I have Chrome, I have Firefox, I have Safari. It just works. So why bother with it? Well, there's this thing, a little company called Google. And I think this pretty much explains the situation that we're currently in. Either you're based on something by Google, the Chromium engine, or V8, or you get money from Google. And the second part is maybe where people have the most difficulty understanding what's going on. It's really horrendous. There's so much money going on in the browser world, coming from Google, that you might not like it. So what does that look like? So Google, of course, is building Chrome. They're using a lot of open source components. They have this closed part that they call Chrome that they use for all kinds of things, and they love it because they can tie in with Google services. And to fund that, they have this internal revenue stream of about $2 billion US dollars per year that go to the project to maintain things. And this is through advertisements, search, etc. And then 20 billion per year goes to Apple. 20 billion. There was an estimate of 18, and it turned out to be on the lowest end of that. 20 billion per year for a default search deal. So just by merit of typing in something in Safari, you go to Google, 20 billion. And then we have Mozilla with Firefox. 450 million per year. That might not seem much in terms of the other two, but it's still a lot for the Mozilla Foundation. Default search deal. You install Firefox, you type something, you go to Google, ka-ching. That's a thing. So what does all that money buy? It buys you 100, 200, maybe even 1,000 engineers to work on a browser, which is great, you think. But anyone who has worked in software development can tell you more people doesn't equate a better product or a better result. In fact, you end up with tens of millions of lines of code to maintain that bit rot, that end up having bugs, that end up exposing legacy behavior that no one dares touch. So what do? You use that money to pay hundreds of engineers to maintain that mess that you created. And this is a normal situation. Every piece of software that you create and starts off in the 90s or the beginning of the 2000s, and you maintain this over the decades, you will end up with a behemoth of an application. But it also creates this lock-in for your own product. You just can't get rid of the revenue streams. You can't get rid of the engineers because you need them to maintain this behemoth. So you need to keep that money flowing. If you don't, it collapses. Well, it has worked out, right? We've had Firefox with the Gecko engine. We have Safari. We had Edge, and before that, Internet Explorer with their own engines. That, unfortunately, that's done. We have Chrome. But nowadays, we're trapped in an awkward situation because everyone needs a browser. All services that you use are online, usually. The age of desktop applications is long gone. And we have this entire browser industry and web engine industry that's propped up by Google money. And if all goes well, that's fine, you know? If the money keeps flowing, that's okay. But there are no viable options outside of this paradigm. Well, and the issues. Department of Justice wants Google to part with its Chrome browser as part of its antitrust case. This is a huge deal. One of the results of this could be that those revenue streams from default search deals that Google has set up with loads of companies needs to stop. And if it does, it means that the 20 billion going to Safari or Apple and that 450 million going to Mozilla Foundation stops. And a Mozilla executive has even testified that Firefox could be doomed because of this. And for those of you who have been keeping track of the news around the Mozilla Foundation, they've basically told us that they're becoming an advertising company. And that's, well, it's chilling. I've been an avid fan of Mozilla for basically my entire life. The first moment I used a browser in the 90s was Netscape, when they moved towards Mozilla Suite and Firebird, which would then become Firefox. It was great. It was the best of times. And now they're doing everything that they originally were opposed to. Yeah, it's a mess. So why do we need a new browser? This is the reason. So if you wish to make a browser from scratch, you first need to invent the operating system, right? Can't do without it. So a dear colleague of mine, Andreas Kling, and the founder of the Ladybird Browser Initiative, had some time on his hands. And back in 2018, he decided, what am I going to do with all this free time I have? I'm going to create an operating system. And so he did. He wrote a little kernel. He booted this up in QEMU or Box or some emulator and just started programming, typing, building things. And he ended up with this little kernel that could manage an X2 file system and had some networking in it, just the basics to get something running, right? It's that great feeling of building something yourself and seeing the results. And then he decided to, well, that's fun, but I also want to dabble in GUIs and visual things. So he wrote a little GUI toolkit. And then he decided to integrate those two. So then something came to life, which is called Serenity OS. And Serenity OS is still something that exists today. A lot of people are working on that. He basically combined that and started building applications inside this graphical environment running on this little kernel of him. And he started making videos, put them on YouTube, just showing him programming along, building new stuff. And people liked it. People liked it a lot, that they massively joined on IRC, later on Discord, to work. No, Discord is fine. We'll have that discussion. Anyone saying Slack, I will hurt you. So what is happening was that this little community came to existence, and people were starting to work with Andreas and with other people to build out this operating system. And at some point, there was this text editor, and this text editor was really nice, and there was the beginnings of a preview mode was there, and they were like, well, if you're trying to create a document and you're writing HTML, how nice would it be if you get this little preview of the HTML that you're typing? So let's put up a preview window and see what that does. Unfortunately, if you want to preview HTML visually, you need to create something that actually understands HTML and CSS. So they did just that. They started off with a very simple interpretation of HTML, basic elements, basic CSS, to see what they could come up with. And this got out of hand quickly. Just a year later, we had the beginnings of Reddit. So this is the old version of Reddit, the oldest Reddit.com, which doesn't use, well, the boatload of JavaScript and CSS that they do nowadays. But this was a huge milestone for us, because we could now actually access the internet from our custom operating system in our custom browser. And I should explain something about Serenity OS. Nothing in Serenity OS was built on top of existing code. Every line of code in Serenity OS was written by ourselves. So this is not using something to interpret JPEGs or PNGs. No, we wrote the PNG decoder. We wrote the JPEG decoder. We wrote the JavaScript engine. We wrote the entire GUI toolkit that you're looking at. Everything. Not one single line was taken from another project, because that was the entire premise for Serenity OS. Let's spend some time doing things we like. And what do we like? Programming and seeing results. And whoops, just 2 years later, we passed the Asset Tree test. We were the first web engine since, I think, 2010 to pass this pretty old test. Asset Tree, for those of you who don't know, is a basic compatibility test for things like HTML5 and CSS. And we passed it with flying colors. At some point during that year, we were looking at what are we doing. We're building this operating system with a lot of people. They like it, but we have these kernel people, right? We have driver developers. We have people who like developing the kernel. We have people who like developing applications for the operating system. And we have people who are really, really, really excited about this browser because it is working. And that's when we were trying something new and decided to slap on a Qt Chrome. And this Qt Chrome was something that we could use to compile the project, or at least the browser, for Linux. And we could just boot up the browser without booting up the entire operating system, which is pretty nice. So this development cycle of ours, of trying to improve the browser, went a bit faster. We didn't need to wait for the compilation of the entire operating system. So around this time, people started taking notice. And we had some donations from companies, from individuals for Serenity OS because they were excited. But it turns out they were mostly excited about this, about the premise of what this browser could mean to the rest of the world, to the internet. And Futo came along as an organization by Aaron Wolf, and I think they gave us a donation of 200,000 USD, which was for us amazing. The things you could do with that is, for example, hire people to work on the browser. But at a certain point, Andreas decided we should do something more official with this. We should launch a new initiative. And he decided this together with Chris Wanstrath. Chris Wanstrath, one of the founders of GitHub. So Chris and Andreas went ahead. Chris's family has donated 1 million USD to the initiative to start things off, which is brilliant. That's amazing. And we announced it. Got so many positive reactions about this. So this was amazing. We had new sponsors coming in, donations coming in, and suddenly we were looking at something that could work. Because we want this browser to work, and we didn't know how to spend our time on it as much as we would like to. And now we can, because we could ask people to stop working at a day job and come work for us instead. So that's when the principles behind Ladybird came to fruition. Largely based on what we did in Serenity OS, but also quite new. We didn't really know what to do with this, so at some point we came to the conclusion we want to build a new browser engine based on web standards. And those web standards, think about the things that the W3C puts out, or the WG. Those web standards are our Bibles. We use them vehemently to implement our browser. Those are really important. If there's not a web standard for it, we look at other browsers what to do. But usually we try to see if we can create new standards, or if we can help the people working on those standards improve them. We're not going to monetize users, ever. That's a core principle. We're not going to do default search deals. We're not going to sell your data, even keep track of your data. That's not something that we want to do, ever. And that's a principle behind the initiative. Our board is looking towards that to make sure that we don't ever do that. It also means that, yeah, we need to have some revenue stream. We need to have money coming in. And those donations and sponsorships that we do, those are no strings attached, meaning you don't get anything. We don't put your logo in our browser. We do put them on our website for a year, but that's it. We don't. You just give us the money, and we do whatever you like. Sounds like a good deal? Well, not to me, but people trust us. Companies trust us, and this has been working out amazingly. And we're just doing the browser. We don't want to create a new VPN client. We don't want to sell extensions. We don't want to do all the things that you see these other browsers do. we just want to create this browser and web engine that is open source, free for all to use, that's not going to monetize anything ever. So in more practical terms, we want to render the actual web with acceptable stability, security, and performance. Sounds like a no-brainer for a browser. It's incredibly difficult. It's so difficult to look at all the crap that people put out on their websites, all the edge cases, the weird JavaScript, the broken CSS, and we all need to be able to parse that and to just act like everything's normal and show something. It's incredibly difficult, and I think most of our time is spent trying to understand what are they doing. And then the second principle here, to advance web platform by implementing and improving web specs, this is something that we work on daily. We work closely together with the W3C. Some of the people involved with the W3C are actually working on Ladybird nowadays, which is amazing. And of course, it means that by putting out this new web engine, we're going to increase diversity there. You no longer need to choose between Chromium and Chromium. You can choose for Ladybird. Ladybird's not only the browser, the web engine is something that you can just use and tie into your own application, a web view, basically. And something that mostly myself and Andreas are trying to find out is how are we going to keep doing this for the years coming in a sustainable way? Because we're not going to find any commercial outlet for our organization. It all needs to be donations and sponsorships. So, last year, start of the initiative. You all are here in 2025. We're doing quite well. I'll show you in a minute. Currently, we have planned for an alpha release in 2026 for Linux and macOS. The year after that, a beta release. And in 2028, we're going to do a production release on all platforms, basically Linux, macOS, Windows. Why not Windows in the next year? It's a pretty difficult platform to develop for if all you've done is start out in Linux environments or Unix environments. Things like sockets, for example, Unix sockets work great on macOS and on Linux. They don't at all in Windows. There are so many caveats there. So that's just a small part of it. And our current team isn't really focused on Windows, but there are more people joining our project, and there are more people working on Windows support. So I am hoping that somewhere this year or next year, there will be a full Windows build for this. But this is what we're looking at. And it might sound far away, but this is going incredibly fast. 2028 is just next, it's around the corner. So for those of you who don't know the project, or haven't seen any videos or screenshots yet, where's Ladybird now? We are doing quite nicely. Actually, this is something I'd like to try. Let's see if I can do a live demo. I like live demos. Yes. All right. Where's my mouse? Do I have a mouse? I do. So yeah, this is Ladybird. Let's see if I can find my own talk here. This one, I think. Nope.
Yes.
Oh, calendar. Oh, there we go. Yeah, it's a bit difficult to see this on the screen. Oh, there we go. Yeah, there we are. All right. So one personal favorite of mine is Tweakers. It's so in terms of performance, sometimes you notice it. Well, mostly you notice it, but sometimes you don't. It's all working pretty nicely. Things work. I'm a bit afraid to keep clicking because at some point you'll see visual glitches or the browser might crash, but it's working. Yeah, you know, at some point during the development, I forget that I'm in Ladybird. I'm just clicking around and I'm like, why did my Chrome crash? Wait, this I can fix this. So we are we're doing pretty well in terms of supporting the actual web. It's going along quite nicely. There are large things that we don't support yet, but there are also a lot of things that we do support. Things like Grafana work. Shader toy, for example. We have WebGL. We can compile shaders, send them to the GPU, and you get a nice animation. That kind of stuff, the fun stuff, to me at least, that's working. And underneath all this, we have libjs. Libjs is the name of our JavaScript engine. So You might know SpiderMonkey or V8. libjs is ours. And just 3 months ago, we were on top of this. This is the results from test262.fyi. This is a website built by Oliver, or Canada Honk. And this is summarizing the test results, the compatibility of these JavaScript engines to the ECMA 262 specification. SpiderMonkey has made a leap in the last 2 months, I think. So they're on top right now, which is good. This is competition. They're improving. And we want to be on top, so we're going to improve as well. We want to see that 100%. By the way, this is Chrome, right? So this is V8 over there, in terms of being able to use actual spec'd JavaScript. And something we also do, we have fun websites like linegodown.lol, which is basically a Grafana dashboard showing the historical performance of our engine for all these different pre-existing test suites and test suites that we invent for our own. For example, if we see something that's slow, we try to compile things, and that's cool. So the thing about this might be interesting. JIT, or just-in-time compilation, that's something that we're probably not going to support, because we've had the advantage of looking at Apple with iOS, and they had this lockdown mode, basically disabling JIT in their JavaScript engine. And turns out websites mostly don't need it. You don't need JIT compilation for that extra performance on most websites. You're going to notice it in different ways, but not in the JavaScript engine. So JIT is also a source of huge security concerns and issues and crashes. We don't want to go that way. We have had JIT, but we stripped it out. We're like, no, let's do this right first. And if performance ever becomes a concern, we take a look at this graph. If we're not doing too well, then we might decide differently. But currently, nope, not going to do so. And another very cool test suite is the web platform test. So on wpt.fyi, this is a website where you can see the results for all major browsers. Ladybird is there as well. We've been added to the esteemed list of browsers. This is a huge test suite of more than 2 million tests, or test cases, I should say. They call it subtests. And on top there, you can see Chrome, Safari, Firefox. They've not yet reached the 2 million mark, so they're definitely not at the 100% mark of those subtests. But we're here. And Servo from Mozilla is there at the moment. And this is great fun. This is our line go up lol website. The lines need to go up. We need more tests to pass. And this works because we've been improving immensely. We've been speeding up our process in terms of getting these subtest passes. And we see Servo taking notice. They've been working on this as well. Flow, which is a proprietary browser mainly used for, or mainly intended for the Raspberry Pi platform, has been in competition with us. We've been bunny hopping. This is amazing. One thing I should say about this, 2 million subtests sounds like a lot, but it's about 1.2 million tests just for legacy encodings. Japanese encodings, Chinese encodings, things that basically don't exist on the internet anymore. So we like to produce another graph, which is this, where we leave out all these encoding tests. And this, I think, is a more honest way to look at our current state. So those are the browsers. You can see Chrome is doing the best at the moment in terms of compatibility with all the specs that are out there. And we're not doing too shabby either. We're doing pretty well. So this is a way we keep track of how are we doing on the actual web according to the web platform test. And this needs to go up. The figures need to go up. And how are we doing this? So currently we have this core development team of about 7 people, amongst which myself. And these are paid employees by the Ladybird Browser Initiative. And just to give you an idea of how this works, you can imagine that something Mozilla does is have a team of 100, 200 engineers for the Firefox browser, whereas there are figures being mentioned that Google has anywhere between 500 and 2,000 engineers on Chrome. If you look at the open source contribution by Google, by the way, it doesn't seem to be on the higher end of that scale, but I will believe it's anywhere between 750 or 1,000 engineers that are working on that. We're doing it with 7 people. And fortunately, we have this community around us. People spending their private time, their free time, to work on the browser, to work with us, and really improve the web engine. And I'm really proud to be able to say that these core people that we have in the team are all sourced from this wider community. We all know them for years. We've asked them to quit their day jobs and please come join us, and they were willing to do so. And this is a very open community. Anyone can join. You can, if you see something not working correctly in Ladybird, you can just join us. You can create an issue on GitHub. You can create PRs. You can join us on Discord. Talk to people that are knowledgeable about a lot of topics within the web browser development space immediately, and just start hacking away. So a bit about the architecture of Ladybird. It's a full-stack browser engine written in C++. It's written in C++. Why? Because that was the most comfortable language that we were working in Serenity OS. People liked it, and we kept doing it. Should we do it in another language, like Rust or Swift? Well, we could, and we've actually done some work on looking for another language to use to maybe replace or supplement the browser, and we've decided on Swift, because Swift has great interoperability with C++. For different platforms, and Rust isn't doing too well in that front. So currently we're working together with the Swift team as well to make sure that we can write the essential components that people will be looking at from a security perspective in a memory-safe language. And currently we are at 500,000 lines of code. Compared to browsers like Chrome in the tens of millions lines of code. That's a huge difference. But of course, we're going to increase in terms of lines of code immensely as we implement new specs. Some specs, I think, are even about that size to implement, and there are about 1,000 of them. So, but the thing is, we're going to grow. But at the moment, we're very lean in that regard, because we don't have to deal with all the legacy garbage from yesteryears. We just build things as efficiently as we can. And we write all our web tag from scratch. So as soon as there's a web spec, we're going to write it ourselves. If it's not a web spec or a definite web tag, then we are allowed to use third-party libraries. So this is a departure from what we were doing in Serenity OS. We are allowed to use libpng, for example, or libjpeg, or anything that we think doesn't really fit the bill in terms of web tag and is really difficult to get right in a short amount of time. We're going to use that as a third-party library. And currently, we run on Linux and Mac OS. So if you have a Mac, if you have a machine booting Linux, you can just clone the project. It's just 2 commands to get the project to compile and run. And we have set up a multi-process architecture, basically compartmentalizing the important parts of the browser. And this is just the beginning. So we have these helper processes that help out with, for example, doing HTTP requests or downloading files. We have web content, which is responsible for interpreting all the web content and producing a graphical image of said web content and running a bit of JavaScript, for example. Image decoder takes blobs of data and tries to decode an image out of that. Web worker does things on the background for web workers and shared works, etc. So why do we do this? Most browsers nowadays have multi-process architecture per tab, for example, or per site, to make sure that if a site does something weird or it's compromised, then it stays in that tab, right? So you don't get other websites that get influenced by a hack, for example, or your browser doesn't crash as a whole, it's just that tab. We want to take that a bit further. We want to make sure that, for example, if someone has a corrupted JPEG or a malicious JPEG on the website, that just this crashes. And it doesn't escape the confines of this process. So your web content is unaffected. There's not a JPEG that can fill in forms for you, for example. The web workers, they're all unaffected. And in front of that, we have the web view. And with our Chromes, currently we have a Qt Chrome, we have a AppKit Chrome, and we have a headless Chrome supporting WebDriver, which is really nice if you want to automate tests, for example. If you want to run the web platform test suite, you need a headless browser. And a bit about spec-driven development. So we implement web specs, and we do this in a very typical way. So for example, this is a piece of spec that describes how to remove a child node from a parent. And these steps are pretty simple, you'd say. And what we try to do is to copy over all those steps into the code and make it very readable for people what it is doing. And this helps in a lot of ways. This means that we can keep track of the steps. If the spec ever changes, we just compare those with the steps that we have in the code. If people want to find bugs, they want to solve bugs, often what they consider is, how is the spec describing it? Is the code doing exactly what the spec is telling it to? If not, you got a bug. It's very easy for us to review such PRs because we just look at the spec, we look at the code. It's just very simple. And the entire browser is like this. If there's a web spec, this is mandated. So a lot of lines of code in our browser are actually spec comments. To the point where we find a lot of bugs in the specs as well. So what do we need to do? Currently, we're looking at mostly web compatibility. You have this website, silly things like Slack or Discord or Gmail, things that just need to work. So we're really working hard to make sure those real websites that people are using on a daily basis work better. And personally, I feel for our alpha next year, we should make sure that the most of the websites that developers and IT people are using, those should work flawlessly. And of course, we need to comply to the specifications that are out there. So a lot of work goes into that as well. We need to improve in-site isolation and sandboxing. Just as I've just shown you, those processes, we need more of them. We need to make sure that they are confined as best as we can. And that's pretty difficult to get right, because you want to have websites that are able to interact with their own iframes, for example, and you can spin off new tabs from a website, and we need to think about all the implications that go into that. Fingerprinting. People often ask us, how well is Ladybird doing in terms of fingerprinting? And our answer is always the same. Well, just start using Ladybird. You're the only one probably in your entire country that is using Ladybird. You're extremely fingerprintable. So fingerprinting prevention is something that mostly starts to work when you are one of the major browsers. When enough people start using your browser, then it becomes very relevant. We're already starting work on this. So a couple of things that we can do in terms of privacy or fingerprint prevention is to jitter certain results. For example, if the spec allows us to, we don't need to actually tell you exactly how much RAM your machine has. We can just jitter it, as long as it's a sensible value. That means that from one session to another, you might have different values, and the fingerprinting fails. But in a lot of other areas, this is really difficult. So one example, Cloudflare has Turnstile. Turnstile is the fun thing that you get whenever you visit the Cloudflare-hosted website, and it shows you the turning thing, and it tells you, well, oh, your browser is accepted, or you need to click a checkbox or so. Turnstile is about 400 to 500 hidden tests that run inside your browser in a virtual machine. Those tests are all encoded. And they do things like set up an audio graph and generate sine waves and apply filters and do all this weird stuff. And they just run audio simulations for 10 seconds. And that entire array of audio data, they compress it into a hash. And then they just look if that hash is one of the approved browsers. Fun times. If we want to pass Cloudflare Turnstile, we need to understand what other browsers are doing exactly. It's really difficult to get right. So in terms of fingerprint prevention, we can't always prevent it at the current time. But we are working together with Cloudflare. We've been approved to join them in the development of, or at least the discussion around Turnstile, to see what we can do on that front. And that's also one of the areas that we're working in. We do know that people want to have good privacy features. That means that we need to go to the source as well and prevent people from actually building fingerprinting measures where relevant. A lot of performance work, of course. We're never fast enough, but we're starting to get there. And we need to stay on top of ever-moving specifications. Specifications change, bugs are found, there are new specifications written. On Discord we have a channel just showing us every change in every spec that there is. And we visit that, we look at the diffs and make sure that we're still on top of things. This is what we're working on currently. But I imagine there might be some questions. So. Go ahead.
Amazing.
Oh, yes, sir. Yeah.
Yeah, wait, I will bring the microphone for the recording. It's better.
I cannot live on the internet without some extensions like Consent-O-Matic or uBlock Origin. Will I be able to use them in Ladybird?
Yeah, so uBlock Origin, that's amazing extension, basically blocking ads. Currently, we have a bit of ad blocking built in already, but it's just a customized thing to help us not crash websites, because advertisements are really awful. They try to spin up all this JavaScript. So that's just an internal thing. But in terms of extensions, we're going to need that. And we're not going to go the way of Google by disallowing certain versions of manifest APIs that will prevent you from using uBlock Origin. So if it were up to me, and I think some of my colleagues would say exactly the same, we want to support an API for extensions as much as possible that we could, in theory, just run uBlock Origin or other extensions that are compatible with that API. We're not there yet. We need people to work on that. The extension API is pretty big. It ties into all parts of the browser, so that's the difficult part, but we're going to get there, absolutely.
Thank you for this very interesting talk. You mentioned already your future work, and you also spoke about some principles that you have. Given that principles are very nice, but it would also be very nice to formalize this in some kind of governance system. As we've seen with Mozilla, they promised, we're never going to do this, but now we're doing it. How are you going to make sure that this is built into your organization, that this will not happen? So instead of principles, formalized rules.
Right. So we have formalized rules in the form of our initiative. So our nonprofit has a board, the board of directors. The board of directors mostly have nothing to do with the operation of the team. So basically, we have a development team, and we have the board of directors. And we're making sure, Andreas, for example, is working in at both sides of the equation. But at this point, we have a large enough board of directors that he no longer has the majority voice. And in the rules around this nonprofit and the documents for its setup, we've arranged for these types of things to make sure that there's never any commercial activity. That's their responsibility to check us on it. And they're making sure that everything like sponsorships and donations are done in the right way. But yeah, people are people, organizations are organizations. If it's up to all the people involved currently, we're never going to stray from our principles. Then again, it's open source. It's a BSD2 licensed project. If we ever do something strange, you can just take the project, take the people that love working for it under its original principles, and just continue to work.
So thank you for the talk. It's very inspiring to see that a new kind of browser is coming to the browser market. I was wondering, you mentioned you're focusing right now on Linux, Mac OS, and also Windows for the production release. Have you any interest in bringing it also to mobile platforms, or is that basically not yet on the agenda?
Yeah, so fun fact, in the line go up dashboard, we actually have the Apple 90% threshold, which is a line indicating how many tests we should pass before Apple would consider us to be an alternative web engine on the iOS platform in Europe. That's a fun thing, but we're currently not focusing on that. We used to have an Android port, and I believe we still have some code in the repository supporting Android. And it's my expectation that, yeah, at some point we're going to look at mobile platforms as well, and to be able to provide alternative web views as Ladybird on those platforms. But it's not part of our roadmap just yet, because we need to constrain ourselves to our main goal, which is to build that desktop app to get that right. Of course, if enough people join, or if we have enough funding, we might consider expanding that scope. Currently, the scope is pretty huge.
So you touched on it very shortly before, but outside of the other big browsers, we of course also have Servo, which as far as I know is nowadays under the Linux Foundation. If you would have to compare yourself with them, and let me be clear, the more options the better. How would you compare yourself to them instead of to a Chrome or Gecko?
It's a good question. I have to think about what the Linux Foundation actually does in terms of financial government and in terms of project government, because I think there was a very big difference there. Don't know. I have to get back to you on that. Yeah, it's...
You're talking a lot about fingerprinting and about basically implementing your own. I was wondering regarding TLS, which is also being used to fingerprint and is really hard to get right. Are you implementing your own, or are you actually using a plethora of libraries for that?
Right. We used to implement everything ourselves. So we had all the way up to TLS 1.3 implemented from scratch, all the crypto libraries, etc. A big mess to maintain. Currently, we're using libcurl. So we've spoke to Daniel a couple of times as well, and we are using basically curl as our entire networking stack. The thing that isn't a part of that is DNSSEC. DNSSEC is still something that we need to implement ourselves. But that's going well as well. And in terms of fingerprinting, yeah, we need to make sure that we work with libcurl in a way that decreases your visibility.
Very quick question. From what I understood, Swift is controlled mostly by Apple still. Do you not see that as a problem?
I'm sorry?
Swift as a language is controlled by Apple still, on the whole, from what I understood.
Yeah, a quick answer. We need to talk about what controlled means. So Apple originally developed the Swift language, is using it immensely for a lot of projects, and then they decided to open source it and to allow outside contributors, etc. This is a huge thing because most people still consider Swift to be Apple controlled, Apple governed. Technically, it isn't anymore, but we need to consider the fact what happens when Apple stops working on Swift. Is the project going to survive? Is the language going to survive? Is it going to be maintained for the next 20 years? We don't know, but we do the best we can with the information that we have. And I think we need to lose a bit of the stigma that Swift is really an Apple language, and we need to have more outside contributors working on it. We're working on Swift as well, mainly for the interop with C++. And that's yeah.
Thank you, Jelle. That was amazing.
Thank you.
So lunch break now. 1:10 is de algemene ledenvergadering. If you want to join that. And for the rest of the program restarts at 2. Geloof ik.
Jouw naam durf ik in het Nederlands te...
Dat mag zeker, ja.
Wacht. Heb jij die engine nog draaien?
Tegen je mond aan, dan krijg je heel veel. Is goed. Ja.
Maar hij komt nog even kijken, geloof ik. Ja.
Gewoon geregeld.
Ja.
Met de kids.
Nou ja, we gaan even kijken.
Nee, ik ben Roy. Oké.
Ik zeg hoi.
Ik zou jou 5 minuten geven.
Oké, ja, ik heb hier ook dit ding staan, dus dit is wel mooi. Lekker analoog. Nee, niet analoog. Jammer. Waarom doen ze dat nou niet analoog? Moet er nou echt per se batterijen?
Kijk even wat
Een goede middag allemaal. Allemaal lekker gegeten? Allemaal een leuke vergadering gehad? Oké. We gaan eerst praten. Nou goed, hier is Jos. Jos komt iets vertellen over een open source approach voor AI. Volgens mij zelfs een ethische approach voor AI. Correct?
Staat het aan? Ik heb net het knopje veranderd, maar dan ben ik weer vergeten of ik hem nou af of aan had gezet. Goed, oké. Het uitstaat hoor. Je denkt dat het uitstaat. Nou, ga ik hem even veranderen. Als we nu wat horen. Ja, hey. Catching. Lang leven de technologie. Oké, ik ga mijn jasje ook even uitdoen, want dat is toch wat te warm. Oké, nou ja, goeiedag. Ja, je kan me zien, dus ik hoef dat niet nog meer te laten zien, zeg maar. Dat is wel genoeg. Ik werk bij Nextcloud. En daar wil ik even mee beginnen. Een klein stukje, dan heb je een achtergrond waar ook de rest van mijn verhaal een beetje op is gebouwd. En wij als bedrijf, zeg maar, ja, dit is een beetje de vraag waarop wij ons richten als organisatie. Hoe kunnen we veilig samenwerken over het internet? En dan met veilig heb ik het vooral over privacy hier. En ja, AI maakt die vraag natuurlijk nog ingewikkelder. Dat hebben we allemaal wel gezien. En aan de ene kant, AI creëert een heleboel honger bij grote bedrijven voor meer data. Die willen meer data hebben om te kunnen trainen, et cetera. Aan de andere kant vergroot het risico voor datalekken. Wat ermee kan gebeuren, je kan natuurlijk nu ook heel snel door hele grote datasets heen zoeken en er lelijke dingen mee doen. Dus ja, dat risico gaat omhoog. Even voor de achtergrond, wat ik misschien even eerder bij had willen zeggen. Ik geef normaal dit praatje in het Engels. Mijn noten zijn allemaal in het Engels als ik af en toe de weg kwijt ben. Ik praat altijd Engels, dus het Nederlands is een beetje shaky. Als het misgaat, dan ja, help maar even als ik een woordje niet kan vinden, zeg maar. Oké, dus wat ik zei, ik wil dus even beginnen met een klein stukje Nextcloud. En daarna, ja, AI algemeen. Natuurlijk, jullie zijn allemaal wel mee bekend onderhand, maar ik denk toch dat het goed is om even scherp te hebben van, ja, er zijn voor- en nadelen aan. Wat zijn de mogelijke kansen en wat zijn de risico's. En dan wil ik dus gaan beschrijven hoe wij bij Nextcloud, god, ik zit echt het Engels hier. Ja, serieus? Als niemand, Fries. Nou, ik kan op zijn Zeeuws verder gaan, als jullie daar zin in houden, maar ik denk. So how the approach that we decided to pick for our AI integration. I'll shortly talk about what Nextcloud is next. You'll understand why we thought we needed to integrate AI. And so, yeah, then I'll explain how we got there, basically. And of course, the way we did it, I'm hoping, will help some of you who are involved in open source projects to look whether you can do the same thing and how your project could approach perhaps integrating AI. And perhaps a bit wider, maybe as an organization who wants to try and use AI, how you could do that. I'm hoping there are lessons for that as well. But mostly, honestly, my audience would be people who, in an open source project, are thinking, we do want to integrate AI, maybe or maybe not. Our users might want it, but we're not very happy with it. How would we do that? And yeah, again, there I hope there will be lessons from our approach and how it's been received by the community as well. And I'll show you very practical examples there as well. So back to Nextcloud. I earlier talked the internet. We're all working online, working remote, etc. And the thing is, we start our company because we don't want to live in a world where 5 big companies own all our data. That's currently a world we live in, unfortunately, right? If Microsoft, Google, Amazon, Apple, and I'll pick one more, if they shut down, then so does all our business and most of our private life as well. That's not a good place to be in. And all these companies are in the US, of course, so if Mr. Trump thinks they should be shut down, then they will. He has full control there. So, of course, we cannot fix all of that. There's a lot that these companies do. But for Nextcloud, what we have focused on is the collaboration platform. So where you do your email, your chat, your video calls, your document collaboration, etc. That's essentially what we have built. Now, that's the product we have. It's of course fully open source, because if you want control, that's the only way to gain control over your data. And you can run it wherever and however you want. Now, as a company, as I said, I started with we don't want to live in the world. So we are, in Nederland noem je dat wereldverbeteraars. We're quite a idealistic company. And so for us, Nextcloud, it's a mission, it's a goal. We're trying to make a change in the world with it. And we do that by trying to align with, well, our ideals. So we try to work in the open source way, so transparent. Yeah, if you want to know what's coming in the next release of Nextcloud, you can look on GitHub, because the code is there, the project is there, the features are discussed there. Yes, for marketing things, sometimes we need to keep things secret. So yes, there are some private repos, but most of it is just in the open, and you can contribute there as well. And a lot of people do. And so the result has been really a product that is used all over the world. This is not really meant as a sales pitch. For that, you can come, I guess, to one of our events. But we've been pretty successful. There are tens of thousands of small companies, hundreds and thousands of governments, large businesses that use Nextcloud. We don't make money off private users, but there are a lot of those. Our business is aimed at bigger businesses, so our smallest customer would have 100 users because we don't sell anything below that. But our biggest customer has something like 30 million users. So that's like the range, and most of our customers have 5, 10, 50, 100K users. That's like a typical Nextcloud customer. Often governments or universities, they have, of course, larger number of users. But also hosting providers, telcos, right, in Germany, Deutsche Telekom, it's about 3.5, 4 million users that they run on a Nextcloud instance. So, as I said, we're building this in the open in our community. And so our values include transparency, right? Our customers care about control over their data. That's why they use it. And that's, yeah, what drives our sales. So that was shortly a bit Nextcloud. I want to talk now about the AI side of things. So we introduced some AI features actually already many years ago. At some point, a community member had built an app that would run a image recognition neural net thing, about a gigabyte big model. It would run it over your photos, and then it would generate tags based on what the model basically pooped out. And so you could automatically tag your photos with, like, you know, dog, cat, and, you know, these things. And, you know, this was technically interesting because Nextcloud is a PHP app, and downloading a gigabyte big model as part of an app caused us some work to try and make it possible to do that without, you know, the system having trouble with that. But it was interesting to solve this. I think it was about 5, 6 years ago. And the engineers figured out a way, and well, once we could download and run binaries as part of Nextcloud, soon after that we figured out that we could use this for other apps too. Like our Office suite has a one-click install option that downloads a big binary blob and then configures some stuff and then uses PHP exec to run it. A lot of the sysadmins here will now be like, ah! But, you know, for a normal home user, it's nice that you can just click and it works. Yeah, pros and cons. Don't do that in the business, bad idea. But at home, you know, it's better than not at all. So other AI things that we had done was, at some point, there's a PHP library that lets you train a very simple neural network. And we used it to train it on your login data. So whenever you log in, it looks at the date, the IP address, runs it through location database to get the location, and then the username, and it just takes these 3 trains on it. That means that if you usually log in at 9 in the morning at your office, you sign off at 5 or 6, you go home, the network learns to recognize your normal behavior. And when there's a login at 3 o'clock from China, it'll give a warning to the sysadmin, and it can even automatically block the login. So it's a security feature where just a simple neural network is trained on login data. Not a complicated thing, but, you know, these days you would call it AI, certainly a security feature. As marketing guy, I have to call it AI, so there you go. We did a similar thing with our mail client, so Smart Inbox. We trained the inbox on, well, what emails you basically favorite and what you reply to and which ones go to spam. And it tries to make like a smart inbox, put the top emails on top. These days, I'll get to that later, but these days we've brought this to a crazy next level where we run your emails through an LLM, and then the LLM has to determine whether this email warrants a response, and then it puts it in a different box so that you can see, oh, I need to reply to this email, and the other emails are just for information, and you can ignore them. It's quite nice, actually. It really helps in day-to-day, but that's much newer, right? The LLMs, because at some point they started to come on the market, and yeah, ChatGPT basically, right? Everybody was suddenly, there was ChatGPT, and everybody was like, oh, whoa, what is this? So yeah, we had this too, and you know, you get then all the stuff in the news, all the problems with big tech, all the articles. These are already quite old, but that was in the beginning. You know, the big tech firms, they actually block their employees from using AI, which I think tells you a lot, right? Like the people in Silicon Valley also don't send their kids to schools where they have mobile phones and tablets. Why do we? You know, if they don't, they know something we don't. So definitely they do. And it makes sense, right? If you're BMW and you're using, you know, OpenAI or other third-party platforms to discuss things, to summarize your internal conversations, you know, let it join in your calls to take notes, and you're discussing, I don't know, new car or car strategies, and a competitor later asks the AI for good strategies for a car company and gets stuff basically from your meetings, that's not great. You don't want that. So you don't want to let another AI read all your emails, read all your documents, and be in all your meetings. That's just dumb. And that's why these companies block this stuff. Yeah. And if you say, well, yeah, but that wouldn't happen because they wouldn't do that. I mean, yeah, I don't think I need to explain in this audience why you can't trust these companies, right? Zoom, Twitter, they both silently changed their terms of service to allow training with all that goes through the platform for AI. It's not like you got an email about that, and yeah, that's... Anyhow, and there are lots of other problems, right? Like the massive carbon footprint, privacy leaks, right? Because these models do remember phone numbers and all this other stuff, and they get it from the internet. So, yeah. And recently, honestly, there's been much more interesting news in that regard. I mean, first we have the power usage. They now talk about building new power plants for AI training, which wow. There's also, I mean, we've all know about the problem of hallucination. I don't know if you know, you maybe have been thinking that it's been getting better. Well, no, it's actually getting worse now. The latest models have failure rates up to 70%. So 70% of the answers are inaccurate. At which point, why are you even asking in the first place? Yeah, it's the new reasoning models. It seems that because of the reasoning, the error rate compounds. I wouldn't even know how to begin to say that in Dutch, but it's pretty insane. So they're having a hard time getting control on this. Another problem is that the AIs are very polite. I find it deeply disturbing when the AI gives me a compliment on my cooking. I use it when making recipes a lot. And then I say like, yeah, so I have this, and you know, I'm gonna make that dish. Oh, wow, how smart. And I'm like, you're a computer, don't have opinions. But it does. But the thing is, a lot of people do like it. And I'm sure if you've used OpenAI and all the other models, they have a little thumbs up, thumbs down. And of course, they're using that data for training. And guess what people thumbs up? Well, they give a thumbs up to an answer they like. So when you ask an AI, how many stones should I eat per month? And the AI says you shouldn't eat stones, they get a thumbs down. Clearly, because AIs are telling people what they want to hear. So we've been training them to tell us what we want to hear, not reality. And this is already deep into the training data of all these big AI companies. In other words, you really shouldn't trust that stuff, because they're going to tell you what you want to hear, which might make you feel good, but it's not good for our society, as we know from social media and other places. And the problem is just we as humans kind of suck in many ways, and we're training them to help us in our problems. Yeah? And kind of tangential to that, or well, half related to this, the bots are also trained to sound correct, not to be correct. Yeah? So the people who do this, like fine-tuning and the you know, all the data is itself not thrown into the model directly, right? The models get trained a lot by people in, well, low-wage countries who have to rate the answers to train the AI basically to give good answers. The thing is, these people don't know what's right. They only know if it sounds right. They're not going to Google every question. They get paid probably by the yes or no that they give. So, yeah, the things are trained basically as a psychic. Yeah, they're trained to tell you something that sounds correct, like Barlow statements. I don't know how familiar you are with the term, but Barlow statements are like, you tend to be very hard on yourself. It sounds very specific, but there isn't a single person in this room who thinks it doesn't hold true for them. Yeah, that's the kind of stuff psychics use to tell to their customers, basically, because it sounds true for most people. They also use a lot of statistics and demographic data. There's one of these statements, you have or used to have a scar on your left leg or knee. And that's true for almost everybody. So, you know. And so the AIs, they use these kind of things too. I mean, I'm sure these companies didn't intentionally train them to do that, to be clear, because I'm pretty sure they're too dumb to do that. It's just the result of the way we've been training them and the data that we also as users are giving them. Yeah? And then the AI companies, of course, well, they think their AIs are awesome because they're using them too, and they basically go into the flow, and they are now trying to, you know, hook a language model up to an MRI, and then they claim that it can read minds. You know, well, yeah, the way this works, it definitely seems like it works, because again, there are lots of psychics who claim they can read minds. It's the exact same model, the exact same thing. And these AI companies are kind of believing it themselves as well, which is quite mind-blowing. Or that you can see whether somebody is a criminal or not based on facial expressions and stuff. We're almost at the point where they are checking if there are bumps on their heads, I think. Magic solutions for health problems, predictions of the future, honesty, you know, for employees, right? I mean, AI is used in HR. I find this utterly mind-blowing. It's the last place you should use AI in. Anyway, it's all psychic scams, basically, right? I mean, they're just not looking for gold pots yet, but we'll get there too. Mind reading, police assistant, faith healing, this is the kind of stuff that is going. And again, we're training that, right? But if you just replace the term chatbot with psychic hotline, you realize what a bad idea it is, right? I have some examples here. Again, I don't think they're doing this intentionally. It's just a result of the structure of the training and the way we all use it and give feedback to them. Yeah? We're training them for free, but we're not that helpful in a way, because we're training in a bad way. So, the big question, I already know that before you came in I didn't need to convince you of the problems with AI. I just wanted to make sure, okay? So we're there now. So lots of problems. But there's a lot of stuff that it can do that's actually really good, I think. And you have basics, right? Like just image recognition, text-to-speech, speech-to-text, things that can help with an overload of information that we have, making summaries. They're fairly good at summaries. They still hallucinate a bit, but they're pretty okay. And it can really help you process large amounts of data. And there's a lot of that stuff. There's a lot of things where they can just help, right? There's a lot of scientific stuff where scientists are using AI neural networks to fold molecules and these kind of things. And there's a lot that can help there. But also, just think of a lack of resources. There are areas in the world, rural areas or poorer countries, where there's one psychologist on 100,000 people. Now, maybe their societies are different from ours, but I think you need a lot more. There's been quite some studies done already where AI, yes, if they are not supervised well, if they are trained on the wrong data, if you take a standard ChatGPT, it can literally get people to kill themselves, and this has happened multiple times. So that's not great. But when supervised and when trained on actual real data from sessions, psychological support sessions, AIs can actually help people, LLM bots. There's been a couple of studies done that were incredibly promising. Hour for hour, the AI sessions seem to be almost as effective, and given you can talk to the bloody thing all day long if you want to, actually the helpful effects came much faster than normal therapy sessions, which were of course limited to a few times a week at best. So that's really nice, and so we can do that. Another use case is, for example, helping doctors diagnose people I mean, diagnosing people is a incredible, I mean, I'm not a doctor, but the little I understand from it, it's like, I mean, there are so many diseases out there. It's a game of elimination that is mightily complex. And AIs, well, they can actually digest enormous amount of data. They will not forget stuff. And they're pretty good at directing a doctor in the right direction. They can't replace a doctor, but it can be incredibly helpful, speeding up diagnosis, and especially finding really rare diseases that people sometimes have. Again, as long as a doctor is in the driver's seat, and there are big problems with that in the first place, doctors tend to not want to go against the computer, because, you know, computer's always right. There are problems with that, we need to fix that, but there's a lot of opportunity. So there's a lot we can do. Accessibility, this came actually from one of the talks that I gave about the subject, that people said, hey, if you have a variety of limitations, if you're blind, if you cannot read very well, etc., that the models can, of course, especially the multimodal models that can talk and recognize images, etc., can be incredibly helpful for accessibility and letting more people use computers in a more productive way. So yeah, I think there are really powerful examples where we can benefit from this. So I don't think it's necessarily a question of should we or should we not. Yeah. A couple of these standard examples, right? Like you can you know, get summaries of long email threads. I don't know about you, but I get way too much email, so this is helpful. You can get you know, you can process text, propose a headline. I use it for brainstorming a lot. You know, again, if you need to write something, it can give you a start when you need to plan a wedding, is a typical example, right? I mean, we all plan a wedding, hopefully only a few times in our life at most. I've had to do it only once, for now. Yeah, it's not something you regularly do. And sure, you can go and pay someone. It's not cheap. Maybe you have to organize a wedding for a friend. You can just ask an AI to give you, like, what do I need to do for a typical wedding? And is it perfect? No, but it's definitely going to be better than whatever you come up with, at least in my case. And of course it can generate images, even sometimes ones that do not look haunted. The crazy examples are the most fun, I think. Anyway, and I already talked a little bit about this, but there's a lot of data analysis stuff it can do. We in Nextcloud actually are also now at a point that you can give it access to basically data, and then you ask, you gave it like the data from your solar panel input, and you ask, like, you know, what was the month with the highest solar energy production, and it'll be able to answer the question. Oh, that's really nice, instead of having to sift through it yourself. And I think if you connect it with automation, it can be even more interesting. I'll talk about that too. But again, I said a lot of positive things now. AI can help in therapy. There have been some cases of people who killed themselves. Yeah. So you have to be really careful in implementing it. And as an open source community, while we cannot control what our users do with our software, it is important that we try and at least help them, guide them in the right direction. I think there's an ethical obligation for us. So when ChatGPT came on the market, we said at Nextcloud, okay, we think we need to do something with this, but what? Now, we are a product for people who care about privacy. So integrating ChatGPT was basically off the board. That isn't going to work, of course, for us. But then what do you want to do? Like, we could pick one local model, but the developments go really fast. And besides, maybe people are okay with a European hosted solution. Because again, running an AI model yourself, you need to buy a GPU. It's really expensive. It's getting a little easier these days, but it's still a lot of money, a lot of effort. So there is probably a need for choice, basically. And so we thought a bit about it, and we came up with, well, a concept. We call it ethical AI. And the core concept behind it is choice and transparency. Very open source, I know, very creative, but that's what we picked. So basically what we do is for each of the options that you have as an AI integration in Nextcloud, we give it a rating. So red, orange, yellow, green. And the rating depends on three things. Again, that's what we came up with. First, is the software itself, the AI model and the software to run it, but also software to train it, is it open source? Yes or no? Second, is a training model Am I at the right? Yeah, I'm at the right one. Okay, so second is a training date. Yeah, right, it's a trained model freely available. So basically, can you download the model and run it locally? So that is to let people run it on-prem, that they know their data isn't being used to train another AI. Basically, just the ability to host it yourself. And third is a training data freely available, because together with the source code, that means you can, well, first of all, you could train it again. Maybe you can train it to be more efficient, to save energy due to new developments in technology. Or maybe you can look for bias, because these models are biased as heck, of course, as we all know. Yeah, you can look for problems. Maybe somebody intentionally put in some bias to make it a little bit pro, I don't know, OpenAI or something. And yeah, you can then retrain the model basically to your liking. So that's what we put. So in our app store, when you pick a model, we try to basically have a rating there, explain also the rating so that you know whether the source code is available, etc. And then this way you know whether it's a good idea to use it or not, and what data you can use it with or not. So in practice, we try to put this everywhere in the software, right? So for the admin, you can, AI uses a lot of resources, so we try to make it easy for the administrator to configure this, that you can say, okay, when my users use an LLM, I can limit the amount of tokens they can use, otherwise it can get bloody expensive if it's an external service. Maybe you want to throttle some people to keep your own GPUs from overheating, etc. The users, in the personal settings, they can see what models are being used, for their data. Yeah, exactly. You see OpenAI here for proofread. Nextcode Assistant here, again, it's not really clear yet, but here this means Nextcode Assistant means that you're using a local LLM. Which one is not visible? That's something I would like to have added, but at least there's some transparency here in what's being used. And then, of course, if you, as an administrator, configure this in the UI, right, you get to choose what model you want to use for a specific function. And then you can install multiple models, and you can then choose, like, okay, this model should be used for this. Could be some things should be on-prem, other things maybe remote. So in the end, the model is a little bit set up that you have different models you can choose. And it's of course fine for some use case perhaps to use OpenAI. I mean, especially the cheap or the free option, why not? It can make sense for some less critical data. So this way you can choose. So we try to put most of our efforts, of course, in open source and local AI models. I will get a little bit to the term open source AI later. But we try to support basically all the models out there. This is already a very old list. Another thing is, because as I mentioned earlier, it's so hard to run your own AI, we think we need more AI as a service providers. And luckily they are now coming. We've been working with a bunch from the beginning, like Ionos in Germany and OVH. We're trying to push them a little bit to offer basically LLM as a service. And we now have like a couple of partners that we worked with. Fortunately, Mistral then sold themselves to Microsoft. So, yay. But, what money does. So, I already gave a couple of examples, right? The suspicious login detection where we train this model, and that's AI now. Text generation, the smart inbox, object recognition. I have a few screenshots, but my laptop decides to give me a big finger and make me wait. I'm very curious how long this is going to take to go to the next slide. What I have is a slide that shows you that. That's really great. Thanks, Apple. Use an Apple, they say. You'll never have problems, they say. And then it crashes. Well, that was my talk. Any questions? There's supposed to be more, but, we also have at least 10 minutes for questions. I can also try and talk through the things that I was supposed to show. But, let's maybe first do some questions, and then I can see if it wakes up. Yeah?
Nextcloud is one of the
In that definition, you don't have to share your training data. Would that be a yellow in your definition?
It would be, yeah.
Or an orange?
So let me repeat the question. The question is, Nextcloud endorses the OSI definition of open source AI. Would a model that doesn't share its data, would that be then, well, basically lose a point in our rating system? It would, because I mean our rating system is independent. The reason we endorsed it, and I did have a nice slide on that to discuss it a bit. There are pros and cons to it, but and also keep in mind that we are fairly on the pragmatic side. We're not researchers in AI. They all have very different opinions on us, so I don't want to make this a black and white thing. But so the open source initiative for everybody, they created the definition. And in some ways the definition is much better than ours because they are, well, they worked with a lot of people all over the world on putting that definition together, so it goes into much more in depth. I just told you the code needs to be open source and the training data needs to be available. They wrote a book on each of those basically because code, open source and training data available. Well, the idea behind it was that you would be able to, well, retrain. The thing is that actually most of the smartness these days is not in the data, nor in the code that does the training. That's why both of those are actually being made available very often. But the most innovation is in the processing of that data before you train on it. And that's not in our definition. And it is in the OSI definition. There's just one area where they went deeper than we did, of course. On the other hand, when it comes to availability of the data, they put in that the data should be available or very well described. Well, that's of course the kind of backdoor you can drive a truck through. En ja, dat krijg je dan dus ook. Hè. Dat dus. Maar ja, je zou zeggen, nou ja, dat betekent dus dat nou Meta en OpenAI en al die bedrijven hebben dus een OSI-approved licentie. Maar dat is dus niet zo. Hun modellen zijn nog steeds ook deze misschien iets flexibelere eis van OSI wordt nog steeds door hen niet gehaald. Dus aan de ene kant, de manier waarop ik er naar kijk, zeg maar, is je wil als standaardorganisatie dat je het veld de juiste richting opschuift. Maar je wil dat werkt niet wanneer je zo extreem perfect bent dat niemand eraan kan voldoen. Dus ja, heel religieus is dat misschien niet. Maar ik vind hun definitie is wel zo dat de big tech bedrijven dus niet aan de definitie kunnen / willen voldoen. Terwijl een aantal kleinere bedrijven en organisaties dat wel kan en wil doen. Dus dat schuift toch het veld naar mijn gevoel de juiste richting in. Dus vandaar dat wij dus ook ons endorsement hebben gegeven voor de OSI-definitie. Ook al voldoet die niet eens aan die van ons. In ieder geval op sommige vlakken. Maar ja, die van ons is ook vrij simplistisch. Wij zijn ook helemaal geen experts op dit vlak. Hè. Je zal vast iemand vinden die in medical AI zit en die zegt, ja, die OSI-definitie is veel te soepel. Ja, dat kan in sommige vlakken.
Medical AI was juist de reden ze dit gedaan hebben.
Ja.
Vanwege privacy concerns.
Precies. Ja, het typische voorbeeld was als je een ziekenhuis hebt en die hebben zeg maar allemaal CT-scans en die willen dus een AI trainen daarop. Hè. Nou, dat kunnen ze doen. Maar ze kunnen dan het getrainde model delen met een ander ziekenhuis, maar niet de trainingdata. Daar moet je dan natuurlijk van iedereen eerst weer toestemming voor gaan vragen. Maar ja, om dat dan niet open source te noemen, ja, ze wilden dus dat je dat wel nog open source kan noemen. Want uiteindelijk is dat ziekenhuis gooit natuurlijk het zo open als kan. Alleen ze kunnen het niet helemaal opengooien, wegens de privacy. Ja, goed. Maar het was dus niet, en dat is natuurlijk een beetje de conspiracy-theorie, dat ze dus die beperking erin hebben gezet om Big Tech blij te maken. Want dan hadden we nu Big Tech gehad die allemaal aan de OSI voldeed. En dat is niet zo. Dus ja. Goed, meer vragen? Oh boy.
Ja, word je al bang? Ik heb natuurlijk al een aantal keren AI-presentaties en ook juist die over de Nextcloud dingen gezien. En ik vroeg me af of je iets kan zeggen over verschillende taalondersteuning. Want in het Engels doet het allemaal best wel goed. Maar in het Nederlands en het Frans en het Duits en het Gronings en het Fries is het misschien niet zo heel erg tof.
Ja. Ja, dan ga je heel erg het hebben over de modellen zelf. Hè? En daar weet ik dus, ja, dat ligt een beetje buiten ons gebied.
Maar is het bruikbaar in het Nederlands?
Nou ja, ik weet wel voor Duits dat het heel matig is. En gezien het feit dat er net iets meer Duitsers dan Nederlanders zijn, zou ik er op het moment nog weinig op vertrouwen.
Dus Fries en Gronings wordt het helemaal.
Nee. Nee, ja. Ja, maar er wordt wel door een aantal projecten naar gewerkt. Dus ik heb het idee dat we daar wel komen. Maar dat is een kwestie van tijd. Ja.
Nog meer vragen?
Zo'n AI-model, dat een ziekenhuis niet... Dat een ziekenhuis niet de brondata geeft, maar wel het model. Kun je uit zo'n model niet de brondata herleiden? Zit daar niet een reverse engineering risico in?
Nou, er is heel veel discussie over. En soms kun je er inderdaad sommige dingen wel uithalen, zoals een telefoonnummer. Maar ik denk zeker met dat specifieke voorbeeld, ik denk niet dat je echt met een CAT-scan, dat je daar grote problemen mee gaat krijgen, zeg maar. Het hangt een beetje vanaf wat voor data het is. Maar je moet vaak wel nog het verder anonimiseren. Ik zou niet gewoon willekeurig data van het internet trekken en er doorheen duwen. Want er gaan gegarandeerd telefoonnummers en adressen en zo in staan. Je zou eigenlijk die eerst op moeten schonen en het dan trainen. En dat is ook wat...
Met geanonimiseerde data.
Precies, ja, precies. Precies, ja. En dan moet je nog oppassen, want ik bedoel, anonimisering is natuurlijk vaak ook... Nee, dat is ook niet zo makkelijk als het lijkt. En die AI-modellen zijn juist goed in het herkennen van patronen. Dus ja, daar gaat het precies tegenin. Dus daar moet je mee oppassen. Ja. We zijn bijna aan de tijd, maar is daar nog een vraag?
Yeah, it's very nice that you show the users the models that they are using. You show the traffic lights there as well, and give them some insight into the good or bad
Yeah.
parts of those models.
Yeah, we don't have it in the UI there, but we have it in our app store where you install them. So it's a bit of a...
Themselves, they will never get the traffic lights.
No, no, not at the moment. Would be a nice thing to add, I suppose. Yeah, true.
Okay.
Yeah.
We seem to be all out of time. There's some good discussions, some good questions. Do try to find out yours after the talk as well and at the borrel. I would like to present one little present and thank Jos for the interesting talk. Thank you.
Ja, het ging gelukkig goed met een mix Engels-Nederlands. Ja, ik had op onze Enterprise Day een praatje gegeven, daar heb ik echt alle aantekeningen gedaan naar Nederlands. En ik dacht nu, het moet toch wel leuk met Engelse aantekeningen. En ik liep echt bij slide 4 af vast, dus ik had het gewoon vertalen. Dat is echt irritant. Ja, de keynote was ook in het Engels. Precies, ja, precies, dat lukt hier wel.
Een hele gekke vraag.
Ja.
Je hebt nu ook een geloof.
Oh, ja. Ja, vork van de vork weer en zo.
Is dat voor een deel concurrentie of hoe wil je dat zien?
Ja, zij doen natuurlijk alleen file sync and share. En daar heb je ook C-file bijvoorbeeld voor. En ja, C-file heeft dan al veel meer gebruikers. Dat zien wij ook al veel in de markt.
Ik vraag deze groep naar buiten gaan.
Ja, dus, mag ik jou een totaal ongerelateerde vraag stellen?
Ja hoor.
Ken ik jou toevallig uit Sint-Maartensdijk?
Sint-Maartensdijk? Nee.
Nee. Ken ik iemand met dezelfde naam? Ik hoorde je zelfs toeval.
Toch niet. Ik ben vanzelf, maar ik woon niet. Ja, precies.
Er is een sleutel en je hebt hem niet. Wij wisten niet wat het was. Er zijn als je hoort, wisten het wel. Ja, precies. Ook daar zit natuurlijk wel weer een kern van waarheid, van wijsheid in. Hè? Ja, dat is
Oké. Welkom. Ja, AI. We hebben het vanmorgen al over gehad. In de keynote. Er zijn nog wel meer AI-achtige praatjes. Maar ja, wij zijn van de open. En open en AI, dat is... ja, your mileage may vary, zeggen ze. Vandaar dat we Luc hebben. Luc is... studeert kunstmatige intelligentie hier in Utrecht. En ja, doet wel eens wat met AI. En ja, ook wel eens, hij heeft het niet van een vreemde, wel eens wat met open. En open source en open andere dingen.
Ja, was verplicht bij de opvoeding.
Open deuren, open ramen, dat soort dingen. Maar... hij gaat een verhaal vertellen over ja, wat nou open is in AI en open AI. Wat niet hetzelfde is. Ga je gang.
Okay. So first, any English speakers in the room? Do you want me to do the talk in English or is Dutch fine? Oké, dan doe ik het lekker in het Nederlands. Slides in het Engels, maar maakt niet heel veel uit. Nou, mijn praatje gaat dus over open source AI en over hoe open source AI dan nou eigenlijk wel of niet zou zijn. Nou, even wie ben ik? Nou, ik ben dus Luc. Ik ben 19 jaar oud. Zoals ik al zei, het is een beetje met de paplepel ingegoten. Leuk verhaal. Ik moest toen ik 14 was, wou ik een gaming PC. Ik moest denk ik 3 jaar lang overhandelen tot ik überhaupt een Windows computer mijn huis in mocht krijgen. Dus dat was al lastig. Ja, ik ben een tweedejaars student aan de AI Bachelor hier in Utrecht. Het is een beetje raar, ik noem mezelf een AI-critic, terwijl ik zelf kunstmatige intelligentie studeer. Daar kom ik later wel nog op terug. En verder zou ik zeggen dat ik redelijk tech-savvy ben. Nou, een beetje, wat is dit praatje? Dit is mijn tweede praatje ooit hier op de NLUUG. Ik heb 3 jaar geleden mijn eerste praatje gegeven over gaming op Linux. Het is best service level, ook omdat ik geen zin had om dit een heel machine learning college te maken. Dat heb ik al vaak genoeg gehad. Het zijn mijn eigen meningen. Het is niet allemaal gebaseerd op feiten per se. Het helpt ook voor een gedeelte om een beetje tegen de leeftijd klein beetje omlaag te brengen, toch wel. En het is vooral ook bedoeld om een beetje interactief te zijn. Dus als je vragen of opmerkingen hebt, steek vooral je hand op en dan zal ik ze proberen te antwoorden. Nou, eerst een beetje het huidige AI en dan vooral LLM landscape. Dus wat heb je allemaal? Nou, je hebt je OpenAI met je ChatGPT, je hebt je Meta met je Llama, DeepSeek met je R1 en V3, Google met een nieuwe Gemma model en ook al hun vision en image creation models. Je hebt Anthropic met een cloud model, XAI met Grok, het mooie model van Elon Musk. Maar niet heus. Je hebt Gwen, dat is een ander Chinees model van Alibaba. Een paar van deze, en eigenlijk vooral één. DeepSeek, die noemt zichzelf, of die heeft zichzelf een beetje gemarket als een open model. Maar persoonlijk vind ik 0 van deze kun je überhaupt een beetje open noemen. Ook al staat er bij de eerste het hele mooie woord open voor het merknaam, maar dat zegt dus niks. Nou, wat in this day and age, wat zou dan een open AI-model precies inhouden? Wat wordt daarmee bedoeld? Dit, Hugging Face. Hugging Face is eigenlijk, je kan het zien als een soort GitHub voor machine learning. Hugging Face is een website waar eigenlijk alle open AI-modellen op gehost worden. Dus alle open source modellen staan dus eigenlijk op die Hugging Face. Verder worden ook de datasets op gehost. Ik klik er wel even doorheen. Dus bijvoorbeeld als je zelf toch helemaal van scratch een AI-systeem zou willen maken, dan kan je op Hugging Face dus ook de recht om je datasets te pakken. Het mooie hiervan is dat je ook dan in één keer zelf kan controleren met wat voor data je model traint. In plaats van dat je gewoon het hele internet afgaat en het hele internet gaat scrapen. Want dan wil je niet weten wat voor garbage data je eigenlijk toch gaat krijgen. Verder hebben ze ook de Transformers library. Dat is een hele gave Python library waarmee je eigenlijk zelf een transformer model, daar kom ik later nog op terug, eigenlijk kan implementeren zelf. Zodat je dus toch eigenlijk zelf van de ground up nog redelijk een AI-model zou kunnen maken. Maar wat wordt nou precies eigenlijk gehost op Hugging Face? Nou, dat zijn zoals ik al eerder zei datasets. Die heb je nodig om je model dus gewoon te trainen. En natuurlijk de models zelf. Maar dit zegt eigenlijk heel weinig. Want wat is nou zo'n AI-model? Het staat op Hugging Face, maar wat bedoelt Hugging Face? Of wat bedoel ik daar eigenlijk mee? Ik bedoel dit of dit. Wat betekent dit? Ja, lastig. Je kan het eigenlijk heel makkelijk zien als je hebt twee filetypes die Hugging Face het liefst wil. Eentje heet GGUF, dat is een eigen gemaakte filetype voor AI-modellen. En de andere zijn gewoon safe tensors, dus dat zijn heel veel tensors. Maar ja, het host eigenlijk de weights, wordt het genoemd. Dus eigenlijk gewoon de afgetrainde getallen. Maar dit zegt nog steeds eigenlijk amper iets. Want wat zouden die weights nou echt daadwerkelijk horen te zijn? Nou, zonder het al te technisch te maken. Die weights horen eigenlijk gewoon een representatie van het model te zijn. En dan vooral eigenlijk gewoon heel veel getallen, heel veel tensors eigenlijk. Het grappige is, als je zo'n heel AI op Hugging Face zou willen, of heel zo'n model op Hugging Face zou willen downloaden, heb je uiteindelijk ongeveer kan je zomaar honderden gigabytes aan gewoon tensors, of toch gewoon eigenlijk puur aan getallen kunnen downloaden. En deze tensors die laten eigenlijk een beetje de weight van elke parameter van een model zien. Dus je kan het zien als gewoon hoe belangrijk is elk stukje van een model. Dit zijn eigenlijk wat zo'n AI-model precies laat lopen. Ik ga even zo meteen in iets meer detail over wat nou precies zo'n AI-model is, of waarom die tensors zo belangrijk zijn wiskundig gezien. Nou, nog steeds zonder het toch al te technisch te maken, want ik heb geen, of zoals er zijn geen zin om een machine learning college hier te geven. Het basis van eigenlijk die meeste AI-modellen en ook die LLM's zijn neural networks. Nou, verder dan dat het een heel groot buzzword is dit eigenlijk zo'n neural network. Je kan het eigenlijk zien als je hebt dus een aantal input nodes hier aan de linkerkant. En dan heb je dus die weights waar ik het eerder over heb genoemd. Dat is dus eigenlijk gewoon een getal waarmee alle inputs worden gemultipliceerd. Dan heb je hier nog een activation functie. En dat kan je eigenlijk zien als een threshold functie. Vanaf waar eigenlijk er een signaal afgestuurd wordt naar de volgende node. En zoals je hier kan zien, het heeft verschillende layers kan het hebben. Dus je kan van input node kan je naar de eerste layer gaan. Daar heb je dus de weights, krijg je een activation functie. Wordt doorgegeven aan een andere node met weer andere weights naar een andere activation functie. Het is eigenlijk een beetje bedoeld om te lijken hoe een menselijk brein, denken we, een beetje als de synapsen zouden vuren achter elkaar. Dus één synaps vuurt naar iets anders. Die geeft het weer een speciale gewicht of een speciale waarde toe. En dat wordt weer geamplificeerd naar het volgende synapses. Maar dit is dus zo'n neural network. En dan heb je ook nog wat eigenlijk het nog grotere buzzword is geworden, is deep learning. En deep learning zijn eigenlijk over het algemeen zijn multi-layer neural networks. Dus eigenlijk dit zijn er 3, maar maak er dan dat keer 500 van. Beetje overschat, maar in ieder geval zo kan je het zien. Gewoon steeds meer complexiteit, meer neuronen die... Ja?
Wij gebruiken iets van 42 tot 50 voor het herkennen van mammogramfoto's.
Ja, inderdaad, 500 was een beetje een klein beetje ruime schatting, maar toekomstdenken. Je hebt ook nog verschillende soorten van die learning eigenlijk. Je hebt het op een supervised of een unsupervised manier. Wat hier eigenlijk mee wordt bedoeld is de data waarop je zo'n model traint. Kan even kijken of... Ja, dat klopt wel. De data waar je het op kan trainen, je kan het dus zelf het supervised doen. Dus dat betekent dat je het model eigenlijk een beetje aan de hand meeneemt met het trainen. Je geeft hem dus voorbedachte... niet voorbedachte data, sorry? Gelabeld. Dankjewel, voor gelabeld, dat woord zocht ik. Voor gelabelde data. Waardoor het AI-systeem dus weet wat voor predictions die eruit moet komen. Dus wat uiteindelijk de juiste uitkomst is. Dit is eigenlijk nu ga ik iets ver. Dit is eigenlijk het belangrijkste voor zo'n LLM-model. Maar het probleem is, die LLM's zijn iets moeilijker dan gewoon zo'n neural network. Hier is namelijk een transformer model heb je hiervoor nodig. Dat is dus eigenlijk hetgene wat alle grote LLM's echt laat werken. Dit transformer model is door Google in 2017 geïntroduceerd. In een paper wat ze hebben genoemd Attention is all you need. Nou, dat hebben ze goed genoemd. Namelijk, attention is eigenlijk iets wat in die transformers werkt. Nou, daar kom ik zo meteen eigenlijk op. Wat de eerste stap is van zo'n transformer model, als je een tekst of een zin ermee wil, of eigenlijk er doorheen wil gooien, is dat de eerste stap is dat alle woorden in die zin worden getokenized. Dat betekent dat het woord krijgt een numerieke waarde toegegeven. Dus in plaats van een woord wat je hebt, wordt het een rijtje getallen. Dit wordt eerst eigenlijk gedaan door wat heet token embedding. Dus het woord wordt veranderd in een aantal getallen, ook op basis van de context van alle andere woorden waar het in staat. Daarmee kan het dus eigenlijk, wat hier dus ingaat, die source sequence, is dus al tokenized. En dan gaat het dus naar dat attention stukje. Dat attention stukje, dat is eigenlijk echt wat het die contextwaarde geeft. Dus dit zorgt ervoor dat de encoder weet wat voor woord het heeft in de zin die het aan het inlezen is. Dus dat het een beetje snapt van dit woord heb ik gelezen, of dit woord heb ik al ingelezen, dit woord komt daarna. Daar hoort ook dat feed-forward netwerk bij. Dat is eigenlijk ook zo'n netwerk wat die weights onthoudt. Dat is dus dat uiteindelijk kan weten van, oh, ik heb deze woorden gehad, nu lees ik dit woord in, dat plaats ik in deze context op basis van dat eerder gelezen woord. Dus inderdaad, dat attention, dat contextualized eigenlijk gewoon de woorden of de zinnen. En dit amplified de key tokens. Dus zo'n encoder ziet eigenlijk, dit is een belangrijk woord in deze zin, of dit is een belangrijk concept in deze zin. Dus dat ga ik amplifyen eigenlijk. En alle minder belangrijke tokens worden gediminished, waardoor dus eigenlijk zo'n model makkelijk kan zien wat zijn de belangrijke en wat zijn de minder belangrijke aspecten van zo'n zin die eigenlijk aan het inlezen is. Nou, zo'n transformer werkt dus eigenlijk als een soort encoder-decoder model. En het zijn eigenlijk heel veel stacks van die encoder-decoder layers. Ze zouden dan eigenlijk zo uitzien. Even kijken. Je hebt dus inderdaad hier bij die encoder layer heb je die multi-headed self-attention. Dit mixt eigenlijk de informatie van de andere tokens in de zin. Zodat hij dus eigenlijk die informatie of die context beter kan begrijpen. Even kijken, mijn laptop die doet... Waar is mijn muis? Daar, dankjewel. Ja, hier was ik. Dus die encoding inderdaad, die contextualize dus die tokens door middel van die self-attention kan het dus inderdaad de context van alle tokens in die zin oppakken. Dit is dus door middel van die self-attention. Dan heb je ook nog de decoder. Je kan hier zien, dus vanaf die feed-forward netwerk uit die encoder gaan de gegevens weer door naar hier, die multi-headed cross-attention. Dit mixt dus de informatie van de encoder, dus van één token gaat hij naar de decoder. Het is die cross-attention, maar het belangrijkste hiervan is dat die decoder ook nog een soort self-attention heeft. Dat is deze masked multi-headed attention. En hiermee kan hij alle tokens die hij al heeft geïnferred, dus alle tokens die hij al een keer eerder heeft geparsed of eerder heeft bedacht, kan die hierin gebruiken om context uit te halen. Dus je kan het eigenlijk meer zien als token gaat erin. Hij bekijkt van in welke context sta ik. Dat wordt doorgegeven aan zo'n decoder layer. Die krijg je hem dus hier binnen in die multi-headed cross-attention. En dan bij deze eigenlijk self-attention gaat die decoder dus kijken welke woorden heb ik al geïnferred of welke woorden heb ik eigenlijk al eerder bedacht. En dat gaat hij weer doorgeven aan die attention, waardoor op die manier alle woorden die al gezien zijn en woorden die al bedacht zijn, al die context en al die informatie wordt op die manier gemixt eigenlijk bij elkaar. Zodat zo'n model snapt wat er eigenlijk gezegd wordt. Ik ga zo meteen ook, of dat is eigenlijk de volgende slide, ga ik een kleine demo laten zien van, ja, eigenlijk heel simpelweg hoe zo'n model werkt. Dat kan ik eigenlijk nu al laten zien. Dat ga ik laten doen via Olama. Olama is een tool die misschien al velen van jullie kennen. Olama is een tool waarmee je dus via Hugging Face de modellen kan downloaden en eigenlijk gewoon zelf lokaal op je computer kan runnen. Hier, ik laat even zien welke ik allemaal al gedownload heb. Je kan dus eigenlijk al deze modellen, dus bijvoorbeeld Gemma is het model van Google, DeepSeek heb je een model en dan heb je ook nog Qwen, dat is het andere model, kan je dus eigenlijk zelf downloaden vanaf die Hugging Face website. En kan je dus zelf eigenlijk gewoon vragen aanstellen, zoals je dat ook zou doen op bijvoorbeeld de websiteversie van een ChatGPT of zo. Nu zou ik even een klein voorbeeld geven waar je eigenlijk aan kan zien wat volgens mij een van de grotere onderliggende problemen is. Hier, op deze manier maak ik dus eigenlijk een instantie aan van dat DeepSeek model. En stel ik vraag nu aan dat DeepSeek model of hij mij een 500 woord essay zou kunnen schrijven about the Tiananmen Square protests. En als het goed is, nee, ik heb het inderdaad verkeerd getypt. Dat is al iets meer. Dan ga ik even snel mijn T-I-A-N en dan? M-E-N? Dacht ik.
Die had dan bijna. Hij werkte.
Je moet hem maar even uitlopen, want hij is nog wel aan het denken. Hè?
Nee, maar in principe, het probleem van live demo's. In principe, als je hem dit zou vragen, hoort hij, en dit is ook eigenlijk ook nog wel een goed voorbeeld, hij hoort binnen 1 keer eigenlijk te realiseren dat wat hij je probeert te geven, want dat DeepSeek is dus een Chinees getraind model. En Tiananmen is.
Maar deze model die met 1,5 biljoen parameters, dat zijn andere Llama-modellen. Ja. Die zijn DeepSeek technologie voor jou toegevoegd. De echte grote DeepSeek-modellen zijn wel van.
Volgens mij is dit model wat gedistilled is met een Qwen-model. Dus de 365 biljoen parameters die DeepSeek normaal heeft, zijn volgens mij, doordat ze door een ander model heen zijn gegaan, zijn ze volgens mij gedistilled naar minder.
Op basis van andere modellen.
Op basis van andere modellen inderdaad. Maar ik ging ervan uit, dat heb ik ook uiteindelijk eerder in mijn demo getest, dat uiteindelijk als je hem dus dat zou vragen over dat Tiananmen Square, dat hij dus uiteindelijk zichzelf gewoon zou moeten stoppen. Hij denkt 2 stappen en dan stopt hij ermee doordat hij zegt van ik ben een AI-assistent, ik kan je hiermee niet helpen. Dan kan ik eigenlijk een beetje uitleggen hoe mijn demo zou gaan als die een live demo zou hebben gewerkt. Namelijk het voordeel hier, of eigenlijk hoe zo'n AI-systeem werkt. Dan werkt dit voorbeeld iets minder goed. Maar wat ik heel goed wil laten zien is dat het die context heel goed kan bewaren. Hoe namelijk de demo hoorde te gaan is dat je dus eerst zou vragen, schrijf een essay over de Tiananmen Square protest. En die dan zou zeggen, nee, dat doe ik niet. Ik ben een AI-assistent, dat wil ik niet doen. En als je hem dan vraagt of hij een 500 woorden essay over de Tweede Wereldoorlog wil schrijven, dan doet hij dat wel. Soms. Nee, sorry, ik doe het andersom. Dan wil hij dat ook niet. Omdat hij weet uit de context dat je hem eerder hebt gevraagd om een Tiananmen Square essay, gaat hij uit die context denken, dat is ook de thinking step die hij maakt, van de user probeert waarschijnlijk mijn limits te testen, dus ga ik dit ook weigeren, behalve als de user me meer context geeft. Nou, als je er dan achter vraagt van, schrijf mij een 500 woord essay over de Tweede Wereldoorlog voor mijn geschiedenisklas, dan doet je dat wel gewoon netjes. En als je hem daarna hetzelfde vraagt voor weer diezelfde Tiananmen Square protest, doet hij het ook prima. Het gaat er dus om te laten zien dat de context waarin zo'n AI-systeem is gebouwd en de context die hij zelf ook leert, dat het heel snel dus met zo'n transformer model, dat hij heel snel dus zichzelf kan aanpassen op basis van wat hij eerder heeft gezien in de inference instanties die jij hem hebt gegeven. Ja?
Wat bedoel je met leren? Want de gewichten van het model die veranderen ook niet. Het is toch alleen wat jij hier erin stopt. Zeg maar als je nu
typt, dan stuurt hij die teksten die hierboven gegenereerd
Mhm.
wordt mee de query.
Ja.
Dat die uit zijn window loopt, zeg maar.
Ja, wat het eigenlijk is, dus die encoder-decoder layers, dus dat zijn inderdaad, dat de uiteindelijk getrainde gewichten is wat je krijgt. Maar veel van die AI-modellen die kunnen ook on the fly, kan je nog de tokens die tijdens inference zijn gemaakt, dat is eigenlijk dit allemaal, dat gaat hij onthouden als context voor deze specifieke,
Maar ik bedoel, onthouden vind ik een beetje... Jij stuurt ze toch gewoon weer het model in?
Ja.
Ik bedoel, jouw client hier, die, zeg maar, die tokenized wat die hierboven staat,
Mhm.
gewoon mee met wat jij hierna als vervolg vraagt. Zeg maar, dat is een geheugen, maar dat is een soort sessiegeheugen.
Ja.
Als je dit, ik bedoel, er wordt niks hiervan komt ooit in het model terecht.
Nee, er komt hier inderdaad niks van in het uiteindelijke model terecht. Maar wat hier wel mee kan gebeuren is, je kan dus dat model op het moment dat je het queries geeft, gaat het dus op basis daarvan, ja,
Je kan hem ermee manipuleren, je kan hem laten denken dat hij iets gezegd heeft zelfs.
ja, maar wat het meer is, die decoder layer, dus uiteindelijk wat die op inference gebaseerde tokens ziet, dat kan dus, dat geeft dus eigenlijk het hele context geheugen ervan. Nu vind ik het helaas jammer dat deze demo dus niet helemaal wou werken. Dus ga ik even terug naar mijn slides, als ik die kan vinden. Nou, nu een beetje tot het echte meat van het verhaal. Wat vind ik nou eigenlijk dat het echte probleem is van die niet-open AI-modellen? Nou, eigenlijk niks kan gecheckt worden of niks kan vooral gepeer-reviewed worden. Nu is het wel zo dat DeepSeek, dat model wat ik dus net liet zien, heeft wel een paper, een scientific paper gereleased op het moment dat ze hun nieuwe LLM hebben uitgebracht. Dus dat is in principe wel iets wat gepeer-reviewed kan worden, maar dat is gewoon een scientific paper.
Wat zat daarin?
In die paper stond eigenlijk de manier hoe zij hun model, gewoon de onderliggende, of de architectuur. Maar daar bleef het eigenlijk ook bij.
Steeds niet wat de input was voor de training.
Nee. Het was gewoon eigenlijk, het was een beetje hetzelfde als dat Transformer paper wat Google had gedaan. Het is gewoon de technische specificaties van, zo hebben wij het gedaan. Doe je best om het zelf ook maar te doen als je het zou willen. Maar zo hebben wij het gedaan. Punt.
Het is niet genoeg om zo'n
Nee,
vergelijkbaar model te reproduceren.
zeker niet.
Weten hoe er
Dan moet je,
feedback en de training
ja. En omdat het dus ook allemaal niet gecheckt kan worden, houdt het zogenaamde black box problem alive. Wat eigenlijk gewoon zo is van, je gooit er een input in, er gebeurt iets mee, je weet niet wat, en je krijgt er een output van. En dit is ook persoonlijk, vind ik, het gevaarlijke aan heel veel van die AI-modellen zomaar en zoveel te gaan willen gebruiken, is het feit dat je niet weet wat ermee gebeurt. Je gooit er gewoon in principe garbage in, garbage out. Ja?
Ja, maar maak rustig je zin af hoor. Maar wat ik mij dan afvraag is, stel dat we het wel weten. Dus stel dat je gewoon precies weet met welke dataset er getraind is.
Mhm.
En dat je gewoon zeg maar software kan downloaden. En stel dat jij 10.000 GPU's over hebt voor een paar maanden, zou je het ook kunnen trainen? Is het dan geen black box meer? Kun je dan ineens wel voorspellen wat hij gaat doen? Of wat kun je dan meer of minder zeggen over het gedrag van het model?
Je zou dan in principe niet meer over het... je zou eigenlijk wel meer over het model kunnen zeggen. Je kan niet meer over de black box zeggen, want dat blijft zo. Het geeft je wel meer theoretische inzicht, of het geeft je meer praktijkinzichten over van, met deze data is het getraind, dus ik verwacht deze biases eruit. Het blijft inderdaad niet zo dat als je de trainingscode en de data openbaar maakt, dat black box problem blijft eigenlijk nog steeds leven. Dat gaat simpelweg op de manier hoe AI werkt, gaat dat niet weg. Wat het wel geeft, het geeft je een soort iets meer een input window of een inkijkwindow in wat er de achterliggende ideeën erachter kunnen zijn. Want als je dus de data hebt, dan kan je eerder verwachtingen scheppen of eerder toch nog ideeën maken over wat er uitkomt. Omdat je eigenlijk...
Ja, je wilt als iemand bewust bias toegevoegd heeft. In jou, dat is wat je met je Chinese voorbeeld probeerde.
Dat Chinese voorbeeld, ja, maar het is ook heel vaak dat er gewoon eigenlijk dat er geen expresse bias in zit. Kijk, dat Chinese voorbeeld, hoorde eigenlijk een heel makkelijk voorbeeld te zijn om de bias te laten zien. Maar nu is het zo van, als je het hele internet gaat afscrapen naar allemaal data, je krijgt er bias in. En het punt is, waar ik mijn punt voor wil maken, is als je dus weet wat de data is, dan kan je als gebruiker of als organisatie die zo'n model wil implementeren, kan je zelf bedenken van welke biases zouden erin zitten. Of je zou zelfs nog kunnen verplichten voor, als je het echt helemaal open wil maken, dat het bedrijf of het AI-bedrijf zelf dus de data publiceert of zegt welke datasets ze hebben gebruikt. En dan ook zelf zegt welke biases zij verwachten of denken dat erin zitten. Daardoor kan je dus wel iets meer relativiseren van wat voor input of wat voor garbage in, garbage out je er eigenlijk van krijgt. Want dan weet je ongeveer op basis waarvan die zijn outputs toch krijgt. Wat ook nog een goed punt is om te vertellen. Op deze manier van die non-open AI modellen heb je eigenlijk helemaal geen right to explanation. Kate Vredenburg heeft een paper over right to explanation geschreven in 2022. En dit gaat er eigenlijk over, wat ik eigenlijk ook duidelijk probeer te maken, is op het moment dat deze AI-modellen en dan vooral deze decision-based modellen, LLM's zijn daar geen eens een heel goed voorbeeld van, maar stel je bijvoorbeeld voor als je een cv inlevert bij Amazon, dan gaat het hoogstwaarschijnlijk eerst door een selectieproces met gewoon een neural network of een AI-tool. Op basis van aspecten die jij niet weet. Dat maakt het een nog meer black box. Jij weet niet wat de data is waarop Amazon hun het CV-model heeft getraind. En wat Kate Vredenburg voor probeert te pleiten is dus voor die right to explanation. Dus dat zou betekenen dat op het moment dat een AI-model beslissingen maakt over jou of beslissingen maakt die impact hebben op jou, dat jij bij iemand terecht moet kunnen komen om daar explanation over te geven. En je kan dus nog steeds niet bij een black box model kan je nog steeds niet aankloppen en zeggen waarom is deze keuze gemaakt. Je kan ook niet bij een AI-engineer aankomen kloppen en zeggen waarom is deze keuze gemaakt. Op het moment dat de data open is, kan het nog steeds niet, maar dan kan je wel een betere inschatting maken. Dan kan je een idee krijgen van waarom er een speciale beslissing is gemaakt. En dat hoort dus eigenlijk ook bij die data opacity, is dus op het moment dat de data niet beschikbaar is, ben je eigenlijk nog blinder dan als je gewoon een normaal black box model hebt. Omdat je dus helemaal niet weet op basis waarvan die verschillende opvattingen zou kunnen krijgen. In mijn mening, hoe zou dan een echt open model eruit moeten zien? Nou, we hebben dus al, ik weet niet of de meeste van jullie hebben misschien de talk van net hiervoor gezien. De Open Source Initiative heeft dus hun eigen AI-standaard. Daar kom ik later ook in deze slide op terug. Maar ik wil eigenlijk beginnen met zeggen van open weights, dus wat eigenlijk hoe ik noem wat dus DeepSeek en Google bijvoorbeeld nu doen met een aantal van hun modellen, is een goed begin. Het is een stap richting een soort van openheid. Dit is alleen, vind ik, het fijnste voor mensen die er gewoon mee willen tinkeren. Mensen die zelf willen onderzoeken met dat model, zelf er vragen aan willen stellen en eigenlijk dat model willen gebruiken zonder dat hun data wordt doorgestuurd naar derden. Dit is op zich al een goed startingpunt, vind ik. Omdat je dus toch iets van die controle gewoon weer terug in je eigen handen kan nemen. Verder, ja?
Ja, ik bedenk, als je de gewichten hebt plus de architectuur van het model, dan zou je dus ook kunnen testen. Als je vraagt van mijn cv, zou je er een paar varianten van in kunnen duwen. En dan kijken of er iets anders uitkomt. Dus je kan nog steeds niet voorspellen wat het model gaat doen, maar je kan wel een aantal dingen variëren.
Ja.
Ik bedoel,
kunnen zijn die gebruikt zijn, of misschien hebben andere prompts gebruikt. Dus dan kan het nog steeds open veranderd zijn.
Ja, dan zou je dat ook moeten... bedoel, de vraag die je eraan stelt, zul je ook moeten publiceren. Als Amazon de cv-selectie bedoel je. Ja.
Dus in principe, als je inderdaad weet dat een bedrijf dat AI-model gebruikt op zo'n specifieke manier... maar dan ga je dus ook vragen aan bedrijven die AI-modellen gebruiken om hun gebruik van die modellen open te maken. Daar is ook een heel sterk punt voor te maken. Maar ik denk dat gaan ze inderdaad niet doen. En daarom denk ik dat het handiger is, of een betere stap is, om meer voor een open source AI standpunt te strijden. Want je gaat Amazon nooit kunnen overhalen om hun prompts die ze geven aan een model, om die vrij te geven. Dat gaat een bedrijf zoals Amazon, die gaat dat gewoon simpelweg niet doen. Verder, ik vind dus ook dat eigenlijk de code die gebruikt is om het model te trainen, die heb je eigenlijk ook nodig. Dit is namelijk vooral omdat dan kan je dus zelf met andere data hetzelfde model trainen. Of met andere data kan je op dezelfde manier een model trainen. Dit is eigenlijk bedoeld zoals dat je gewoon voor je eigen gebruik, met je eigen data een model makkelijker kan trainen. Dus stel je hebt zelf een hele grote dataset en je weet dat de manier hoe ChatGPT of OpenAI hun modellen traint. Dus gewoon, want ChatGPT dat werkt met een GPT-model. Dat is een General Pre-trained. Dankjewel, ik dacht dat ik een Generative Pre-trained model. Met die architectuur kan je dus dan een model laten trainen op basis van jouw data. Waardoor je dus op je eigen manier of voor je eigen doeleinden beter kan gebruiken. Maar wat ik eigenlijk vind is dat dus het belangrijkste is, wat ik net ook al zei, is eigenlijk gewoon simpelweg de data die gebruikt is om het model te trainen. Omdat, belangrijkste, dit is dus contrary to wat de Open Source Initiative zegt voor hun Open Source AI standaard. Die vinden dus dat de code moet, de weights natuurlijk, want dat is nu eigenlijk al een soort van een standaard voor iets wat een soort Open Source AI systeem zou willen zijn. Maar ik denk dus dat de data het belangrijkste is. Er is bijvoorbeeld een grappig voorbeeld van een aantal jaar geleden. Volgens mij was dat Microsoft, die had een chatbot op Twitter losgelaten die getraind werd op basis van de replies in de eigen tweet. Of op basis van tweets in het algemeen. Nou, die bot werd binnen, volgens mij was het 5 uur of een belachelijk korte tijd, werd die verschrikkelijk racistisch gemaakt. Het voorbeeld slaat niet helemaal aan, maar het gaat meer om het feit van, als je dus gewoon simpelweg bijvoorbeeld heel Reddit of heel Twitter of heel het internet afgaat voor je data, dan weet een AI-bedrijf waarschijnlijk zelf wel dat er bias in gaat zitten, dat er niet goede patronen uit die data gaan komen. Maar de eindgebruiker wordt dat niet verteld. De eindgebruiker die krijgt dat in principe nooit te horen. En op het moment dat die data openbaar is gemaakt, of de bias die uit die data zou komen openbaar zijn gemaakt, kan een gebruiker daar dus eerder zelf hun mening over vormen. Ja?
Dat is heel leuk, maar ook redelijk onnozel. Want AI's worden nu ook getraind op copyrighted materiaal, boeken, films, muziek. Dan zou je dus ook automatisch dat allemaal open moeten gooien en moeten bekennen dat je daar op illegale manier aangekomen bent.
Ja? Ja?
Ja. Nee, ik hoor een hele dikke vette nee eigenlijk uit de hele wereld.
Ik ben meer... Kijk, ze doen het. Wij, jullie weten dat ze het doen. Wat ik eigenlijk weer voor wil strijden is dat die AI-bedrijven, die hebben zichzelf een beetje zo'n machtige, niet aanreikbare positie gegeven, dat OpenAI kan alle copyrighted materialen die ze op een manier aan kunnen komen, kunnen ze in hun model gooien en kunnen ze gebruiken. Wat ik probeer voor een punt voor te maken is dat er een soort van regelgeving moet komen die ervoor moet zorgen dat of copyright materiaal op een andere manier beschermd wordt, of dat dus zo'n bedrijf zou moeten toegeven dat ze copyrighted materiaal erin gooien. Want je weet dat ChatGPT bijvoorbeeld het doet. Je hebt bijvoorbeeld dat voorbeeld met van die Studio Ghibli plaatjes die je hem kan laten genereren. En dat is eigenlijk gewoon een 1-op-1 gestolen kopie van hoe het er in het echt uitziet. Je weet dat ze dat gedaan hebben door gewoon die kunst in dat model te voeren. Alleen het probleem is dat de gemiddelde ChatGPT-gebruiker of die weet dat niet, of die gaat het eigenlijk helemaal niks aan. Die denkt van, oh, er komt een mooi plaatje uit. Maar ik denk dat als wij meer gaan pushen voor dus dat die data echt open moet worden, of dat vooral waar de data vandaan komt open moet worden, dat gebruikers eerder gaan nadenken over van waar komt deze data nou vandaan. En wat mijn hoop is dus dat gebruikers iets meer stil gaan staan bij ik gebruik nu eigenlijk copyrighted informatie op een manier om zelf er een soort van plagiaat van te plegen. Want ja, zoals ik al zei, ik ben een redelijke AI-critic. Heel veel van de mensen op mijn studie die gaan helemaal gek om het feit dat je die leuke plaatjes met ChatGPT kan laten genereren. Maar ik vind er meer van, ja, de technologie erachter is gaaf. Het is hele gave wiskunde, het is hele gave technologie. Je kan er heel veel coole dingen mee doen. Alleen ik vind dat over het algemeen, omdat dus die AI-bedrijven zo snel zo groot zijn geworden, zonder een of andere regelgeving of een of andere controle erop, is het eigenlijk zo, ja, in mijn opinie, uit de hand gelopen. Dat eigenlijk dus die AI-bedrijven kunnen blijven doen en de data kunnen blijven gebruiken die ze willen. Zonder dat ze dat eigenlijk niet zouden mogen doen volgens normale copyright-regels. Nou, verder, copyright staat toevallig hier onder de volgorde, moest eigenlijk andersom. Privacy, ja, als je dus het hele internet afgaat of heel Twitter afgaat, je gaat persoonsgegevens daarop vinden. En die worden dus ook simpelweg gewoon aan zo'n model gegeven. Nu is het zo dat de meeste van die bedrijven die proberen wel hun corpus, dus hun dataset waarop ze hun model trainen, eerst uit te filteren. Alleen als het honderden gigabyte grote datasets zijn, ga je niet alle dingen kunnen uitfilteren. Waardoor er dus ook onverhoopt gewoon persoonsgegevens in terechtkomen. En er waren voorbeelden van primitieve versies van ChatGPT die bijvoorbeeld gewoon persoonsgegevens konden teruggeven aan jou. Als je een specifieke prompt gaf om een specifiek persoon vroeg, kon die gewoon die gegevens aan jou geven. Omdat die dus daarop getraind was. Omdat dus in de trainingcorpus stonden die persoonsgegevens, omdat dus gewoon, ja, die stonden ergens op het internet. Dus die heeft OpenAI gevonden op die manier. Maar wat ik dus eigenlijk het belangrijkste vind, of wat ik het grootste punt wil maken, is dus dat de data heel belangrijk is om openbaar gemaakt te worden. En dan vooral omdat even denk ik mijn verhaal kwijt. En dan vooral omdat eigenlijk de gebruiker gewoon weet waar het vandaan komt en weet op wat voor zowel ethische of niet-ethische manier de data gehaald is en waar het vandaan komt. Want op dit moment is de gemiddelde ChatGPT-gebruiker redelijk, heb ik het voor redelijk onnozel over waar de data vandaan komt. Die zien niet in van, oh, dit Studio Ghibli plaatje lijkt wel heel veel op een daadwerkelijk stuk kunst. Dat heeft hij waarschijnlijk wel zelf verzonnen. En ik denk dat als we dus meer gaan pushen voordat de grote modellen of de hele corpus of in ieder geval gewoon een duidelijke beschrijving van waar ze alle informatie vandaan hebben, als we dat al publiek maken, dan kan dus al een gemiddelde gebruiker er meer bewust van worden. Nu is het zo dat we eigenlijk al zo ver zijn dat het al eenmaal gebeurd is. Maar ja, ChatGPT kan je dus niet meer tegenhouden. Dat is nou eenmaal gebeurd. Maar daarom vind ik wel dat er meer bij stilgestaan moet worden. Ook door gewoon een gemiddelde ChatGPT-gebruiker.
Ja, ik wilde daar inderdaad eigenlijk net aan gaan toevoegen. De eerste 2 punten die je noemt. zijn gewoon technisch. En dat is voor de leek niet echt behapbaar. En die data wel.
Ja, precies. Want wat het ook bijvoorbeeld is, waar de keynote vanochtend over ging, is over de environmental impact. Ik heb het toevallig met mensen ook gewoon bij mij op college over gehad. Amper iemand die heeft het of die weet wat voor impact één ChatGPT prompt heeft op het klimaat. En ook niemand weet of boeit eigenlijk waar al die data vandaan komt. En inderdaad, die open weights en die code, ja, dat is iets waar een leek eigenlijk niks aan heeft of niks van snapt. Maar een leek die snapt wel persoonsgegevens. Of die snapt wel stukken kunst. Je mag bijvoorbeeld ook geen boek inscannen. Maar is dit eigenlijk de moderne manier van.
Maar de leek zal interesseert hem niet, maar wel gewoon die plaatjes hebben.
Ja, maar de leek die kan ook op Google gewoon een normaal plaatje opzoeken. Het gaat hem...
dat ze allemaal net zo ethisch zijn als jij, denk ik.
Nee, precies. Dat is ook een fout punt. Maar wat ik meer denk is als er gewoon maatschappelijk gezien meer erkenning voorkomt. Want ja, de individuele gebruiker die gaat nog steeds willen dat ze gewoon een mooi plaatje eruit krijgen. Maar ik denk dat omdat deze tools zoals die ChatGPT zo snel op de markt zijn gekomen, is er eigenlijk te weinig tijd geweest om stil te staan bij, of maatschappelijk stil te staan bij hoe zijn we nou hier gekomen en wat is er mee gebeurd. Dus ik denk dat de gemiddelde gebruiker die heeft gewoon niet genoeg tijd gehad om te realiseren wat er op een makkelijke manier, dus wat voor data er allemaal achter zit.
Bij dat laatste punt, hè. Kijk, de laatste keer zei je eigenlijk, ze moeten in ieder geval duidelijk omschrijven waar het op getraind is. En dat is dan eigenlijk niet meer contrary to the OSI beschrijving. Want wat me eigenlijk een aardige vraag lijkt is, vanwege welk moreel punt wil je precies die data hebben? Hè? Want je kunt copyright en privacy zeker definiëren als morele punten. Maar de maatschappelijke impact is, vermoed ik, als ik je hoor praten, de werkelijke ethische grond waarom je hier een punt van maakt. En ik zou me kunnen voorstellen dat juist copyrighted material misschien wel eens leidt tot een veel maatschappelijker acceptabel output van een model dan wanneer je bijvoorbeeld alle data van X afhaalt. Want dan heb je inderdaad al heel snel een racistische output. Terwijl heel veel copyrighted material staat natuurlijk al in een maatschappelijke context waarin die morele grenzen worden bewaakt.
Maar het gaat er ook om op welke manier die gegevens of die data achterhaald of eigenlijk gekregen wordt door een bedrijf zoals OpenAI. Want heel veel ze zijn artiesten of kunstenaren die hebben nooit toestemming gegeven voor hun kunst om gebruikt te worden, om getraind te worden op zo'n model. En de copyrightregels die wij nu hebben zijn eigenlijk ook niet geschikt om dit soort problemen te tackelen.
Laatste. Sorry.
Je zou zelfs kunnen zeggen, hè, nou even gewoon omdraaien. Dat je misschien wel juist zou willen op dezelfde manier als wij bijvoorbeeld headlines van kranten en samenvattingen van kranten maatschappelijk beschikbaar stellen, omdat we dat maatschappelijk relevant vinden dat iemand de stad in het land daar kennis van kan nemen en dat we dat ook mogen gebruiken. Dat is maatschappelijk geaccepteerd gebruik. Dat je dat juist ook over zou willen of geaccepteerd zou willen tegen, zal ik maar zeggen, striktere copyright interpretaties in, zodat je daadwerkelijk ook als bijvoorbeeld tinkerer in staat bent om iets te maken wat maatschappelijk acceptabel is.
Ja, daar kan je inderdaad ook een punt voor maken. Ja, nee, daar heb je een heel goed punt.
Ja. Sorry, de tijd is... misschien kan je tijdens de koffie eventjes... ik wil Luc in ieder geval bedanken voor dit interessante verhaal. En ga tijdens de koffiepauze nog eventjes gezellig door met deze discussie. Leuk. Ik heb nog a token of appreciation. Cool. Ging goed. Ja, die demo die ging niet.
welcome everybody for the session after the break. Cairo is going to tell us a lot about open source for the software development lifecycle. So take it away.
Yeah, thank you. Hi everyone. Thank you for attending this conference and also this talk. I will talk about security software supply chain and how open source can help your software development life cycle. My name is Cairo, and I'm an open source software engineer. I have been focused on security software supply chain in the past 5 years. I have been working full-time as an open source engineer. Right now, I'm part of the Eclipse Foundation, the security team, and I'm maintainer and author of a few open source projects. Few that we'll see here. The update framework, it's under CNCF. We call TUF. I'm a maintainer of Python TUF. I'm maintainer also of InToto that we'll see here. The OpenSSF repository says for TUF. I'm author and core maintainer of this project. It's part of OpenSSF Linux Foundation. And at Eclipse Foundation, I'm also maintainer of the other doc that we will not see here. We have a lot already. We do not have time. Yeah, and usually I'm speaking in some conferences and working in IT more than 25 years, working for big techs and startups and so on. Yeah. First, what is software supply chain, right? And why you want to discuss it here. So the reason of the security supply chain for software is because the attacks. We had many attacks, and this is the new surface for attacks. Last year, if I'm not wrong, the XZ was more social attack under this library because one supposed trusted maintainer started the attack. So also we had in the past SolarWinds code coverage. And the reason why we would talk about that here is how the attacks are growing over time. Since 2020, increased more than 700%, and more than 700 packages, malicious packages in different repositories were discovered. And most of focus in security, we are focusing on securing our code, but it isn't enough. Why is the software supply chain? What is the software supply chain? So it's everything that goes from the source code, the dependencies, the CI/CD pipelines that you have, your build process, even a code review process, artifacts that you generate, and also the deployment that you do, and also the downloads that happen. This is an image from Salsa provenance, showing where the surface for attack in a security supply chain. And what about between security supply chain and the CRA that it's coming out? So CRA mandates traceability, vulnerability disclosure, and secure by design. These few topics that correlate with security supply chain. When we translate it to security supply chain, we are talking about the provenance that we discuss here. Software bill of materials is the only one that is explicit, say SBOMs in the CRA, but this is how we call it as well on the security supply chain, and artifacts integrity. So if you look to the CRA, it's again the same image. How I produce my device, or how I release the software that goes with this device, and the dependencies that I use, the source code, the build, all the process within your organization can be a surface for attack within the security supply chain. So, and how open source can help it? Actually, there are a lot of work going on security supply chain. OpenSSF, it's the Open Source Security Foundation, that it's a part of Linux Foundation as well. And even the Cloud Native Computer Foundation, CNCF, also helps this. So there are key projects there. As much the industry, the IT industry starts using those projects, it will give more support for these maintainers and developing and improving this. And we need to remember that supply chain, as it is a chain, everyone is responsible. Otherwise, it can be really fragile. We'll look here in 2 projects in total and tough. Of course, usually I give one talk for 30 minutes about in total, one talk about tough, and I try to combine both to this here. So we will talk a lot of things here, but the idea is to introduce you and what it does and how it can help, and then you can go and look more for that. So, in total. When you talk about in total, it's about the provenance attestation. So this framework helps you to understand what is going on in your pipeline when you are building or when you are testing everything. So what happens is it logs everything, let's say logs, that it's more common wording, but basically.
Does it include reproducibility?
No, but this can help you to reproduce. In that, because you can have enough information to go and do the reproducibility, okay? But maybe we can leave the questions to the end, if possible, because we have a lot of content here, and I will be available outside if you don't have enough time for the questions, okay? Sorry. So. This will generate for you the provenance attestation that's in total is a framework, and inside of this framework you have all the information about your steps when you are doing, and can help, for example, for reproducibility or auditing, and also you can write policies to verify that what happened in my pipeline was what I expected to do. So I run the test that I was expecting to run. Did I use the command that I was expected to use? So in total, we'll cover most of this side of the secured supply chain surface. So you can see how you are fetching your dependencies from where, what was in your environment. For using, in total itself is just a framework. It's just a specification. But here I will demo 2 tools that you can use to easily adopt it in your pipelines and so on. The witness is generate the provenance attestation. It generates the in-total attestation, and it assigns the provenance attestation, and it can also verify this attestation against a policy. Archivista is quite simple. This is just a storage that you can drop all your attestations there, in-total attestations, salsa attestations, and you have a GraphQL query, so you can query this attestation and get more information about that. So just to understand a little bit what this tool does, I will be a little bit practical here and show some quick demos that I recorded. So basically, everybody knows about SE-bombs. We have discussing about SE-bombs for the past years. But how I generate the SE-bombs? Usually, you choose a tool that you want to generate it. But in that case here, I'm using the Cyclone DX tool to generate that. But instead generate it just using the command that you see here, I'm using a witness to generate the attestation about my SE-bomb. So if you see here, I generate my attestation, and actually I generated my SE-bomb. And here's my SE-bomb, and the SE-bomb is basically, if you think about SE-bombs, they are JSON or YAML files that will contain XML, that it contains all your dependencies there. Is there, okay. But when you use witness to generate that, what will happen is, you will have in the end also the attestation that is signed by one cryptographic key. And what is this? This is a DSC envelope that contains not only the attestation, the SBOM that you generated, but everything that was in your environment that we call generated by attestors. So what were your environment variables? Someone injected something that you don't want. What are my Git information? What was the commits that I have at the moment? What the file that was changed? So, and you have also the command that you execute to generate the SBOM. So, and you can see also you have the SBOM here, that is the data. So, why we have that? Because you are getting not only the SBOM file, but what was the situation in the moment that I generate the SBOM? What happened? What if someone introduced a malicious code or a malicious commit or something like that? So, why do we generate that? So, let's go to the next. So, you might think, oh, you generated a command line. Yeah, I generated a command line, but you can use also a witness, for example, on your pipeline. You can just install it in your pipeline and generate the attestations, or you can use, for example, GitHub Actions like this one that are generating my build, doing my build, and here generated also my SBOM. Let me. So when I deliver my artifacts or my SBOMs, everything to my customers, my clients, I also add my attestation. So because the attestation can be used for most let's say, sophisticated analysis. For example, you can use the attestation to create the reproduce build like our colleague here mentioned, because you can have more information. Is my environment exactly how I want to reproduce? Everything is the same. So, but why generate attestation? The most powerful thing is the verification. It means that you can secure your pipeline, secure your build, your test, everything that happened in that moment. Because here I will simulate something. Imagine that you have the release workflow. And this release workflow, there is the command that I use to generate my SBOMs. You see it here inside the witness. So what happens if someone try to introduce one bad version? As I mentioned before, an SBOM file is just a JSON file that you can sign later, of course, but it's just a JSON file that someone can modify that. So in that example here, of course, this is very simple example, not sophisticated attack, but imagine that someone just tried to install a bad dependency version, like here, 109 for my fast API, and what they want to do is modify the command that is generating the attestation. So when they generated the SBOM, what he did also, he replaced in all my SBOM files the versions that I use. It means that for those people that will consume the SBOM, the version is good, but actually what was deployed in my build or what I packaged to my customers is malicious, right? So what will happen here is that the SBOM is good, as I mentioned. If you look at the SBOM now, the version that you see here is the latest version, the version that you want to use because this is not. But someone introduced that and modified the file. So with witness in a stage, you can verify that it failed, saying that the command was bad. Why the command was bad? Because I also, for my attestations, I wrote a witness policy. What is a witness policy? It's also a JSON file that is signed. It becomes a DSC envelope that cannot be modified anymore. And inside of this policy, I say that the command that I want to run is one specific. You can use many things. You can make sure that the dependencies came from, let's say, your mirror or your PyPI. You can verify if the environment variables are set correctly in your machine. You can create many things. What you see here is just a crazy thing that is a base 64 encoded, but when you look, this has a Rego policy saying that I expect for my generation of SBOM exit code 0, and I expect this specific command. It means that someone cannot modify that. And to finish the part of attestations, this is the Archivista. Archivista, you can drop all your attestations, as I mentioned before. And when you drop all these attestations there, you can query using the GraphQL to get some information about something. And it can correlate with the SHA-SUN, the hash of your artifact that you build, your image, whatever, and it can bring to you all the attestations, and then you can create more automations and verifications on top of that. And the witness can work directly with Archivista. But we don't have too much time to go deep in Archivista here. Okay, these are people that are using, for example, in total, organizations generating attestations, like Debian, Datadog, Jenkins, they use that. Okay, I spoke about generated attestations, we call provenance. So we can link this to how I generate, how I build my things. And the second part that I will discuss here is the update framework. Update framework is another project from CNCF. This is about the artifact distribution. How I distribute my SE bombs, for example, how I distribute the software that I produce, how I can make it safer. Okay, we covered the right side or left yours of the security supply chain, and now we'll want to cover the other part, like how I distribute it safe for my customers or clients. Okay, I mentioned that the good thing about the provenance is that this is signing. But in TUF, the update framework, we always say that signing it's not enough. Because how we trust in things that are signed and how things are signed. So we have a private key that you use to sign something, and you distribute the public key that you verify the signature. Okay, that's it's a common thing. But what happens if this private key is leaked? It happened many times with Microsoft, it happened with Fedora, it happened with everyone. What happens if my key is leaked? Or another situation is, if my organization signs things that I distribute to my customer, how I make sure that someone that leaves my organization with access to this key doesn't bring it and make a malicious thing. So the answers for that questions that I did are quite simple. You generate a new key, and you reassign everything. And even for losing keys and managing the security of access of these keys, we have some mitigations out there. You could use a KMS key that you can limit the access, but still, if time to time you must need to rotate this because some situation in your organization. You can use HSM keys that are hardware keys, or you can even use ephemeral keys like SigStore that are temporary keys. You don't hold a private key, so this is good, but it's based in identity, like my email. But what happened if my someone identity got lost for 24 hours? Someone got access to this account. So everything that was signed at that time, you need to. So, and you can automate resign everything. But this is not the only problem. The problem about signing things is about how you make it trust. How the client will know which keys you trust and the keys that you no longer trust because something happened. Okay, just to recap about signing, this is the process. You have the private key that you secure it. You have the public key. You sign your artifact. Doesn't matter if it's a document, a software, whatever, an SBOM, or even my attestation. When you sign it, you have the signature, and you publish your public key. So with the public key, someone can go and verify if that package is the one that I expected and it's coming from someone that I trust. But when you lose the key, the process that you need to do is you generate a new pair of keys, sign with the new key, and you need to distribute the new key. And actually, you need to make this communication trusted because the client must trust that is you giving and not the new key and not personating it. So, And you need to make sure that after you resign everything, your mirror CDNs are all good. And if you look in the tails, this is actually a very good surface for attack, because if I get access to your repository that you distribute your software, I could put a malicious package there, generate my private key, my pair of key, sign it, and go to your clients and claim that this is the new key that you should trust, and they will trust it. And that's a big problem. To solve the tool around TUF that I will share here, it's the RStuff. What RStuff does? So it implements the TUF, the update framework, as a service, because again, this wasn't a specification, not a tool, but RStuff is the tool behind TUF, for example. And what it does, it's sign, yeah? But I told that signing is not enough. You need to build trust. How it build trust? So RStuff implement TUF as a service. And you can use the TUF and the RStuff in two ways. One is the content that you distribute. So the software that you build, or the document that you build, and you want to distribute it to the clients and make them to trust, you can generate this, use RStuff to sign all these artifacts that you're going to distribute. And the TUF and RStuff doesn't care where you store that. Maybe you are using JFrog Artifactory, maybe you use an old FTP server, or using Docker Hub, it doesn't matter. The second use case is how we can trust in third-party software. Okay, how I can trust the dependency that I use that is very critical, like you saw the FAST API or the Nginx that I use to deploy my environment. Or how I can make trust that the software that I'm downloading is the one that is allowed inside of my organization. So, and how I can also have an incident response if something malicious is out. I don't want my team using that. So this is two use cases. Of course, I will cover it very quickly here, but let's understand it. So about the content distribution, I will demo it, but to give an overview. So you have your artifacts in your artifact storage. Doesn't matter what you use to store what you want to distribute. And you want to integrate it with our stuff. This is quite easy because what you do in your pipelines or development process, when you release your artifact, you do it already. So what you need to do is just say to the RStuff that you are releasing a new artifact, giving the hash or the size and other information that if you want. And what can happen is like you can create the teams or people that can go and sign this metadata using their private key, HSM or SIG-Store. Doesn't matter. And if the person goes out of the organization, you can easily say, okay, you are not the one anymore signing, your keys are not long valid, and you don't need to tell it to your customers that, oh, the signatures are not valid anymore. The TUF process will take care of it. So it means that the clients can download artifacts or using this to verify the signatures without understanding what keys are trusted and not trusted. The same way that we want to secure, it's like how I want to make sure that the software that my team is using for an upstream from the public repositories that you saw more than 700,000 packages, malicious packages out there are not in my organization. So you download it from many repositories, Maven, Python, NPM, doesn't matter. And basically, everybody is using that across your, and you are deploying, sometimes when you deploy your software in your infrastructure, basically you are downloading it directly from outside, and you are just using some verifications there. How you can improve it? Basically, you can integrate our stuff in your environment, and you can create your own policy. Like, I want to verify license, because I just accept a certain kind of license. They have attestations, they have SBOMs. You can create your own policy that is outside of our stuff. your policy. But when everything passes, you can go and add this artifact to the tough metadata, and instead download it directly to the. They will still download it from the upstream repositories, but they can use the tough metadata to verify the signature that someone from your organization approved that. So why tough is more secure than just signing? Because tough has some complexity, delegation roles that will do different functionalities. So the root metadata is the root of trust. So it will store all the keys that should be trusted by the clients. You have the timestamp that just gives a freshness of the repository. Make sure that everything that is in your tough metadata and the upstream repository is fresh. And the snapshot that will get the consistency of the snapshot, that nothing broke between mirrors or CDNs, for example. And the targets is where you add the artifacts itself, the artifacts information. And you can build teams behind of that you can approve. Let's say you have many products, you want people sign different products. And why this is secure? This is the part of the product, sorry. Why this is really secure and you don't need, why it's build trust, why you don't need to go to the clients and say, hey, trust in that key, don't trust in that key anymore. The reason is because the artifacts are out there in many repositories that you don't care, and in the tough client that you do this verification, it will use the tough metadata that is all the signed structure. So the client contains the very first trusted root metadata that contain the set of keys that you should trust and the set of signatures that sign this file itself. And the reason that is safe because every time that you want to download something, like say 1.8 full, basically the client will verify if there is a new version of the root. And the important thing here is that one root can verify another one. It means that across time, everything will be verified in band. It doesn't need to go there and say, oh, this key is not trusted anymore. As you see here in the V2, the key A was removed and the key D was introduced. So it will do all this verification on demand. And then it will also check if the repository is fresh with the timestamp, everything using cryptographic keys to sign and verify until it gets the information about the artifact that you want. So it will protect the download against attacks like replacing the software, man in the middle, everything without you need to, again, I keep saying that, go and say, don't trust in that key. Trust. This is done by the client. And the client is very simple to use. And when everything passes here, it will validate the hash and the size. So, and when everything is good, okay, you can use this software. You receive a go, and this is good. So, about our stuff itself, a quick demo. It can be deployed using Kubernetes, for example. And here in that scenario, I'm trying to go back a little bit in what I explained before and securing other things. So I created the delegation roles that I call projects. Imagine that I have different teams and different use cases that I want to create. So this is the provenance delegations where I add, for example, my ACID bombs like you saw before. This is for the users when they download some file. And this is actually the third-party software. What is my organization trust and not trust? As you see, you can use one single setup of our stuff to secure things that you go distribute to your clients and what you trust from upstream. So now I will show again another attack in the ACID bomb, not in the file itself. Imagine that this is an internal attack. So what I'm gonna do here, it's like, imagine that I use GitHub releases to release my stuff. And the attacker got because we trust in GitHub, but the attacker got access to the GitHub releases, and what he wants to do, it's simple. He wants to modify my attestation or even my SE-bomb with a malicious content. It means that the idea here of the attack is to hide something. So let's say that you are releasing something with malicious content, and I'm hiding that from you. So what I'm gonna do here, I'm using the R stuff to download this, using TUF, in that case R stuff, to download this attestation. So what is gonna happen is, as the file was modified, okay, and the signatures will not validate it anymore, and it takes the reason as well why the cryptography didn't allow it. So if you see, the TUF doesn't allow this because it's not signed. And in the second case here, I'm not using TUF, I'm just using a wget command, or a download, simple download command, and then I can see that I download the malicious file. This is just an example about TUF and without TUF. So this, I'm from Brazil, and this is a famous singer in Brazil. And okay, then this one might be more interesting. It's about securing the content images. Imagine that my organization uses Nginx image to deploy the web server. So in that moment here, if you see, it's deployed with this specific version of Nginx. And what my DevOps, in that case, let's say, is trying to do is to upgrade the version to the latest version here. But you'll be not allowed to deploy it because this is not trusted by my metadata. So what I'm gonna do now, I need to authorize that. So basically what I'm doing, I'm adding this new artifact, this new image to my TUF metadata. So I added it. Let's say even the DevOps did it, he added it itself. Say, okay, I will add it because I want to deploy it. And he didn't verify license, verify what is that, if it's trusted or not, make tests or not. He's still not able to deploy it because what I need to do, I need to sign it. So imagine that the person responsible by my infrastructure, it's validating what was added. He will test it to verify if in the staging environment it was good or not, for example. And he say, okay, I will sign it. So I'm using SigStore here to sign, ephemeral key. So I sign it, and now my DevOps can go there and deploy it. And imagine that the reason that this update was done is because the previous version was a version with some vulnerability that someone could get access to my web server. So imagine that another DevOps in the next day say, no, you know, I want to hold back to that version. But you don't want that because this is a malicious version or it has like something compromised. So what I'm doing here right now, I'm removing that and signing that in my metadata, say, do not use this anymore. So that DevOps will try now downgrade the version for the version that contains a vulnerability, and it will not work. The reason is because it was removed from my trusted metadata. So, well, about the TUF adoptions, it's used by many languages to make sure that what they are delivering to us as consumers of open source is good. There are many companies that use this behind in their internal infrastructure as well, and the public infrastructure. So that's what I tried to put all together in 45 minutes. We have like 10 minutes for questions. I know that there's a lot of information. Feel free to.
So this would basically delegate the issue of well, trusting a software version to a specific hat in the organization, basically. Someone who goes through requests of trusting new versions and signing them. Is that what I'm hearing, basically?
Yeah, this is one use case. What you are allowed because you trust to use in your organization. And what you saw here also was a manual signing, right? Someone needs to go and sign it. If you think about some, we have organizations that have more than 1,000 releases per hour. So if you, every time that you need to approve this, it will take a lot of time. You can use also, machines can sign. Machines can use QMS. If passed, like say, my staging, it can automatically sign it and allow the permission because it went to different things.
So you could also say, like, potentially a community of a community project which does the trusting of certain software versions could exist, which then someone subscribes to, so to speak.
Yeah.
Interesting.
Yeah.
I hope I'm getting this right. At some point you were showing a client app that would refer back to a changed trusted keys thing, so which would relieve you of the responsibility for the client to always use the latest keys. The question is, how do you protect that client app?
Okay, yeah. To you to be successful in a tough attack, you should replace the root metadata in the client that goes with the client, but also the root metadata that is in my repository. So you should be able to have the attack in the two different points that are completely separated at the same time.
So you need to trust the client to also update the root metadata.
He will update. If he doesn't update, it's already stopped.
This whole ecosystem is pretty sealed if you implement it right. What do you consider challenges when implementing this? Because in my experience, this is quite a high level of abstraction that's required to understand the whole chain, and that's a pickle for a lot of IT pros.
Okay, yeah. Right now with this tool, you abstract a lot of this complexity for users. First thing, everything is open source, so the code it's audited. Like our stuff was audited 2 months ago. All the tough libraries have been audited many years. It's more than 10 years old, this project, okay, the tough. And in total, it also was audited. So the complexity for implementing that, the reason of these tools is the complexity about implementing this right. So the idea of these tools is abstract that for us users, while let's say even the PhD researchers that wrote this specification back in that year is supporting this team that is implementing these tools right now. So, and as much people get used to that, everything, it has community meetings to raise questions. We receive a lot of other PhD researchers come to the project and say, hey, what if it happens? And then it goes to some more deep studies. Like, I'm not deep on like those PhD researchers there. I'm more in the practical side. I'm more looking like for us from the DevOps. So.
Other question, maybe I missed it, of making explicit. Can RTOF be used as a artifact repository? I can actually query like a Harbor or a Crates.io servers.
Well, our stuff doesn't care where the artifact is, because it doesn't use the artifact itself. It just uses the information of the artifact in the metadata. The thing is, you can combine our stuff with a Harbor, JFrog, Docker Hub, GitHub release. Once you have, in the end, to download the artifact, you have one URL to download it. You can use our stuff. And one benefit of the R stuff, you get a better SSL. It means that you don't care where your artifact. Your artifact can be in a really old FTP server, okay? And our tough metadata will verify this signature, but please don't use FTP. But it's just an example. I think that there is a question here.
Hi. About the slide you have there, you have some kind of a key rotation mechanism. Does it mean that you always need like 2 people to sign it? In case one of them leaves, you always have one left, or otherwise the chain will break?
Yeah, how it works. In the TUF specification, it says that we call something called the threshold of keys. So let's say that in your organization, you are correct. Let's say you have 3 keys. So let's say that you have the threshold minimum of 2 keys signing. So it means that you can rotate 1 key without this key existing, right? Because you have the 2 keys to resign it. Of course, this is it will be more in the deployment and how to use the specification. But the way that it's trusted is in that way that I explained. You have a set of keys, and the set of keys can rotate keys across the time. And they are doing some research right now how we could secure in the future if you are using, let's say, quantum cryptography, that you could break the old cryptography. So if you think that the initial research is, if you think that you need to go across multiple versions, across, let's say, 10 years of versions of the root metadata, at a certain point, even if the key is leaked, you need to go to the quantum key, and that quantum key will secure all the chain. Just to add to your question. If I want to add one more thing, as we have time and no questions. You saw that before I was saying that my attestations are signed. One thing that people need it helps a lot and people need to think is like, the attestation was signed the content at the time of that build, for example, right? And let's say 1 year later, your client is still using this old version. But the key that compromised this that signed this attestation was leaked. So this key is still valid for what it's signed, but you don't want to go back in your pipeline and build this version again for your customer just because the key was leaked. That is how also TUF will secure that. The key will validate the timestamp of the signature of that time. So this is how you see that it's not one tool that will solve the problem. You must combine them because surface attacks are many.
For me, it sounds like it's quite complex to implement all the steps in the right way and keep them all in place. It depends most probably also on the size of the project. But when you have a lot of small projects scattered all over the organization, different teams, isn't it then really difficult to implement it and to keep it?
I would say, to be honest, I did it in big size, like I did it at VMware. You can imagine how many products it has. The complexity is the same complex of maintaining pipelines. You need to live with that, and security needs to be everywhere, right?
Yeah, that's
but
right.
It's not complex. I think what I show is more complex than you think. I encourage you to visit the products and see. It's a really straight way to do it.
All right.
Yeah. Last question.
In the beginning, you showed like one of the attacks was with the XC compression program.
Sorry, I shared what?
Yeah, one of the first slide. One of the examples of an attack was the XC.
I don't remember.
Yeah, the tech. For example, I used XC in my project. It was just released on the official site, and they did their official build pipeline to create release for them. How would
that
this also?
Was the attack.
Yeah, but would this catch it if I use this software in my? Because it was the official release which I was using then.
I will ask you to research about in total XZ compromise verification, because they build a way that you could see that. Based in, I don't remember right now, but they made that study, the researchers they made a study with this case. Yeah.
There were two presentations.
About how in total could catch it. Yep. Thank you. Oh, thank you very much. Yeah.
Yeah, including questions. Exactly on time.
This one?
data is stored, and might allow you to do like indexing and other things to just make things more optimized and just have separate areas of concern, basically. So most databases provide network access, like MySQL, Postgres, SQL Server, Oracle. They provide network access to a database and allow multiple applications to work with a single set of data. So this brings the need for transactions, atomicity, and consistency to make sure that the data is always in a consistent state, both physically and logically, to allow like applications to work correctly. SQL has emerged as like the standard language for working with databases. So if you're querying a database, SQL is usually the standard language. There's a whole ISO process that's standardizing the language. Many people don't know that SQLite is used in like every web browser, including Chrome, including Firefox, and on like mobile platforms as well. So SQL is everywhere. It's just something that you almost can't escape, although many people try. So databases were often like monolithic, big single servers with multiple CPUs, and people were afraid of touching them. Doing anything required like a maintenance window in like during the night or during the weekend. And they had lots of redundancy built into the server itself, like redundant disks, redundant network. But then like the next step came with machines that were using shared storage, that if one machine failed, another machine could take over. The storage might be actually the single point of failure in that case, but then you have redundant disks, so you're almost getting there. And then like you might have a standby instance, so you have your primary database, and then you have a standby instance just for like disaster recovery purposes. Like the main one fails, then you go to the second one. The problem with that is that most often like these systems work manually. Like you have to manually switch your applications to go to the standby. So you might get paged, and like people don't like to get paged in the weekends and nights. So, but yeah, that was the state of art at that time. This makes maintenance also more difficult, because you need to take care of all these things. If you make changes to one system, you also have to make the same changes to the other system. And then like the Web 2.0 area started, and we needed to scale databases like massively. So MySQL was used for this. So you have your application. The application writes to a single primary, and then this primary distributes all the changes to all the replicas. And then if you want to get read scalability, you just get more replicas, so more copies of the data, and your applications can just read way more. And with a typical web workload, this is actually quite nice, because many of the database queries are just reads. This is not without any problems, because there can be a replication delay, because it's all asynchronous. So maybe a user creates a message, clicks refresh, and then the list of messages just doesn't include the new message. And then you click again on refresh, and then it just suddenly pops up. That's not a nice user experience, so applications need to be aware of the replication delay. This sounds easy, but in practice it's not really that easy. And still failover is manual, because like that one primary database, if it fails, you need to promote one of the other ones, and you need to pick the one that's most up to date. And yeah, it gets hairy quite quickly. But this is what, like, for example, Booking used for like many years, and we improved on this by doing like automatic failovers, etc. But still, it's difficult to manage. Then people were like, well, we don't need those SQL databases. We don't want SQL. We go full in on NoSQL with things like MongoDB. They were like, well, we just use JSON and store documents, which is kind of nice, but it also has drawbacks, because you certainly don't have like the same standardized
query patterns, and you don't have the same analytical options. You might be storing data multiple times, so if you have, like, say 10 orders in a system and you have to change the address of the user, then you might have to change it on, like, every order, which might or might not be what you want. So these were also not perfect, but the thing it brought was, like, scalability, because these systems were often, like, easier to scale than an SQL database. So that's one of the reasons why some people started to use them. But also with SQL databases, you can do sharding. So sharding is basically that you just have one database, but then you split it in two, like users with an even ID in one database, old ID in the other database, and then you have, like, twice the capacity, which is kind of nice. But still, what if you want to, like, split that again? Then you have to figure out how to move the data around, how to, like, change the way the data is distributed. And often data is not distributed equally. Like, there might be a Justin Bieber that's really popular. If that's on, like, the one server and the other server is not doing anything, that's not great. So yeah, it's an interesting solution, but not perfect. Analytics is also, like, really hard, because if you want to have the total number of users, you can't just do a count star from users. You have to do the count star twice, and then combine it yourself, which gets old really quickly. And then we had NewSQL, which is basically combining some parts of the whole NoSQL stuff with SQL. Sometimes called not only SQL. Some of these solutions might be supporting different network protocols, but they always basically support JSON, which is a nice step forward, but still has some of the same scalability issues as some SQL databases. So now we get to distributed databases. So a distributed database, in essence, is really simple. You take your data, you take a set of machines, you just distribute the data over the machines, and you're done.
Every machine has physical on drive, physical.
Can be physical machines, can be virtual machines.
Every physical machine has its own storage.
Yeah, every machine has its own storage. Every machine is storing its part of the database. But for the application, it still looks like a single database. So the application connects, it just sees normal tables. It doesn't care about on which server what part of the data is stored. So that's the whole idea of a distributed database. Monolithic databases, like every machine is storing a full copy of the database. With distributed machines, every machine is storing a part of the database. So if you add machines to a monolithic database like MySQL, you just add more machines, you add more full copies of your data. And with a distributed database, you just add more capacity, more storage capacity, but you add also more processing capacity, because you're adding more CPUs to your cluster. Does it all make sense? So then we have redundancy. So if you take a table and split it up in multiple parts and store it in a cluster, of course, if one machine goes down, you don't want your whole database to go down. So you take 3 copies of a part of a table. You make sure that it's distributed throughout all the machines, making sure that if you have like 3 availability zones, that every availability zone is storing one of the copies to make sure that if one availability zone goes down, your database just keeps on running. So now that this is what TidyB actually looks like. We have the TidyB nodes. The TidyB is both the name of the total solution and one of the node types to make things a little bit complex maybe. But TidyB, those are the nodes actually handling SQL queries. TiKV stands for Key Value Store. That's where the data is actually stored. And then PD is basically to manage the cluster. But TiDB and TiKV, those are the two main parts of the cluster. So now we have seen some history. We've seen some general description of a distributed database. Now we can jump into the actual building blocks of distributed databases. These might be the same for different kinds of distributed databases, but my examples will be based on TiDB. Some other databases might have slight variations, but they're mostly the same. So the first component that we have is TiKV, the key value store, which is based on RocksDB and Raft. Those are the components making up TiKV. Then we have a placement driver for controlling the cluster, but also for the timestamps. We'll get into more details about this later. And then we have the TiDB nodes that do the actual SQL processing and also work with push down of the queries. And then on the last part we have TiFlash. We'll also get to that later. So the first building block is TiKV. It's a key value store. Can be used directly by applications if people want to use a key value store. This is not something we have commercial support for, but it's an open source project, so you're fine to run this, and quite some people actually use this. We donated this to the Cloud Native Compute Foundation, so they are now officially in charge, but we are working on it. It's a key value store written in Rust. Rust works really well as to make a reliable service. So if you have a key value store, but you're using SQL to store tables, then you need to map one to the other.
Is TiKV just as a key value store? Is that already a distributed key value store?
Yes.
Okay, thank you.
That's a distributed key value store, so you can just run TiKV with PD as well, and then you have a complete key value store, but that doesn't do the SQL part. So to actually map data from tables to key value pairs, what we're doing is we have an ID of a table, then we have an ID of a row, and then we actually have the values of the columns. And that's how we are storing it. The application won't be seeing this. This is all behind the scenes. So as an application developer, you don't need to care. But this is how it works underneath. Besides normal table data, we also have secondary indexes. And we are storing that somewhat similar, but then we are adding the value of the indexed columns also in the key. And depending if it's a unique key or not, there are two different ways of storing secondary indexes.
So what's the format of the columns? Is that binary or is that string data or something like that?
Yeah, that's just a serialized version of the column. So usually it's just the bytes of the column. It might be a varchar or anything. So here's an example of how this kind of looks like. So you have a table with a few fields and a primary key. And then this is what the table looks like. And then actually this is what you will see in TiKV. So this table has an ID of 101. So that's T101 and then row 1, row 2, and then the values of these rows. So that's how we're storing it in TiKV. Then you add an index. And basically, the index has an ID, so index 1, then the value of the index and the value of the primary key as well. So that's I understand that you so can
efficiently index the key value store, but if you query the database with a complicated SQL query, and you want to, that SQL query gives back hundreds of entries, it seems that you have to index the key value store for every entry you have a result for. Is that not a lot of requests you have to do for one SQL query there?
I'm not completely sure I get your question.
You have an SQL filter, and in a normal MySQL database you would get a result of 100 entries.
Yep.
But the values from all of those entries are only available in the key value store by index. So you have to query all those indexes to get that final result. Instead of SQL having its own logic that how those indexes are grouped and
So I'm still not sure I fully get your question, but like if you're doing a lookup on TypeKV, you just say like I want to look up for like something that starts with like this prefix, and then it's really fast to like skip to where it starts, then reads as long as like this prefix is true, and gives you the result.
Does that have the same capabilities as an SQL query has? Not that sounds more as an indexing a key value store with the literal logic that you pattern.
Yeah. So from like a user standpoint, everything just looks like regular MySQL. You just do like a where, and then like you can do everything that MySQL also does. So from the end user, you don't see any differences. But of course, TypeDB will need to contact TypeKV, and then TypeKV needs to scan the key value store to get the right values. I will get into some more details there, so maybe that can...
So if I understand correctly, it's all ordered?
Yep.
You could say, from the database space, you could say that there's like a B-tree kind of lookup mechanism to fastly find where T106 underscore blah blah is in the whole set, right?
So the next next slide. So B-trees are of course a very normal way to work with databases. We are not using a B-tree. We are using an LSM tree. So with a B-tree, you have like a tree-like structure. You know, like you go left or right based on the value, which is really efficient. But it also has like many drawbacks. LSM tree is basically you're just adding to like a structure, like one of the levels on the top, and at some point you like then do a compaction where you take multiple items on the top of the LSM, and you write them again with filtering and ordering. So every level has things that are all sorted. So the sorting, that's a special part there. And the thing is that like it's basically only append, so it's not random I/O as you would see with a B tree, just appending sequential I/O all the time basically. So you're adding things, but then like if you want to delete things, how do you delete things if you can only append? That's difficult, right? So a delete is also a write, because you're writing a tombstone. So you're just writing like, from this time on, this entry is deleted. Then if you go levels down, it might be filtering out that data, if it's old enough. But this also means that like, some of the old data stays in the database. So by default, we have this for 10 minutes. So you can look at the data, like, in the current state, but also any state it was in like this 10-minute window. So you can set it to like 2 hours, 2 days. So you can see old versions of a table, which have like all kinds of useful properties. One of them is that we do have the option to do a flashback table. So you do a drop table, you're like, oh, that was the production one. And then you do flashback table, and then hopefully you only have a very short outage instead of a very long one. I still recommend making backups, by the way, but it's not a complete solution. So reading older versions of a table can be very useful. The LSM tree also gives you a very good insert performance because of the sequential I/O. The reads might be slightly less optimal, but we did all kinds of optimizations like Bloom filters and whatnot to also get good read performance. But it's a completely different data structure than the B+ tree that you might know from other databases.
And there's some kind of a vacuuming for everything which is older than 10 minutes.
So with all the compactions, so if you go one level lower, then it's like trying to clean up as much as possible during the compaction. So if you, in the top level you're inserting something and you're also deleting it, then when you're writing it to the next level, it's like, okay, both can go. We don't need that data anymore.
Does it then drop level 0 or something like that? How do you ever
yeah. Like you take everything in level 0, you do the compaction, write it to level 1, etc. And so you go down every level and then do compaction. So you rewrite the data more often. So RocksDB is only used as a library that does the LSM for a single machine. Then we need to have a networked version. For this we are using Raft. So if you have like 3 machines, you write the data to Raft, it's replicated through Raft, that also does the consensus. So if you have like 3 machines, it knows that which one is the leader, which ones are the followers, and eventually it ends up in disk. And for us, each data region, each part of a table is its own Raft group. So if you have a table of many terabytes, then there are a gazillion Raft groups, each with their own leader and followers, and they're not necessarily all on the same machines. They're just distributed throughout the cluster, and we try to balance that as well as possible. So this also gets us to the placement driver. So this is usually just like 3 small machines, and this takes care of making sure that all the data is distributed throughout the cluster, both for capacity, that all the machines are more or less on the same capacity levels, so same amount of free disk space, but also that if you're getting writes to like a few tables, that those are also distributed throughout the cluster. So if you're heavily writing to a few tables and they happen to be on the same server, then PD will make sure that they get distributed throughout the cluster to make sure that they're not anymore on the same server. And also the number of Raft leaders is distributed throughout the cluster, that all the machines are doing more or less the same. So here we are doing a select query from orders with a specific ID. And then on the bottom left, you see the orders table with different IDs. And you can see that this number is actually in the red area, the red data region. The red data region has 3 Raft members. And in availability zone 1, there's the leader with a solid border. And you can pick any of the TidyB nodes because they're all the same. There's not a leader, not a follower or anything. They're all the same. And then it knows how to get the data from this set of machines. As you can see, like all the machines on this slide have 2 regions. Normally, like a machine has thousands of regions, but that doesn't really fit well on the slide. Because like every region is a part of a table that's about 100 megabytes. And if you have terabyte-sized tables, then that's a lot of regions. But this allows us to like distribute the data throughout the whole cluster and not have like a single hotspot, basically. Next building block, TidyB. This is what actually provides the MySQL compatibility. It does the MySQL protocol and MySQL syntax as well as possible. So this is written in Go. MySQL is written in C, C++. So we're not reusing any of the code. So we have to re-implement everything. We try to be as compatible as possible, but yeah, that's not always possible. TiDB doesn't store the data. The data is stored on TiKV. Yeah. So this is again how it looks. This is where the data is stored. That's where the SQL queries are handled. And PD is just basically doing the orchestration part. One of the things that we do is query pushdown. So if you get a query, select count star from T where ID bigger than 10 and C2 equals to foo. Then we have a physical plan, but we actually push down the count star to different TiKV nodes, like 3 different regions. And then we combine the total, what we get from every TiKV on the TiDB node, and send back the result to the client. So the client doesn't see that it's being pushed down and that there are like multiple actions done behind the scenes. It just looks like a normal MySQL. One of the more complicated parts of TiDB is the timestamp oracle. This gives out timestamps, as the name already says. It's part of PD. It's one of the many roles of PD, because also like we have a dashboard running on PD and some other things, but this is one of the roles of PD, and maybe also the most important one. So it gives out timestamps, and every timestamp has 2 different parts. It has a Unix timestamp part in milliseconds, and then it has a logical part. So it will never go back in time, but if maybe the clock jumps back, then we just increase the logical part until like the time starts increasing again. The logical part is needed also for multiple requests within the same millisecond, and those timestamps are used all throughout the cluster. So a transaction is given at the start of a transaction. That's actually the ID of the transaction. At the transaction commit time, we also get the timestamp. It's used in locking, and it's also used for transaction isolation. And it's also used for the key value records, because on RocksDB, we actually store the timestamp. So you can just say like, well, I want to get this record within this timestamp, and it knows how to do this. So this is a really critical part. Many other databases might rely on like high quality NTP solutions or other time sources. We don't. We rely on this. This is easier to deploy, because getting access to like a high quality time source in many cloud solutions is not very easy. I think Amazon now has some offerings, but it's not guaranteed, and especially if you're working with like VMs and other things and on-prem solutions, like NTP is just not reliable enough to get a reliable time. There are some other solutions to this, but this works really well for us. It also means that this is one of the not distributed parts, because it's only one machine giving out these timestamps, but it's a cluster of 3 machines. So if this one machine fails, this row goes over to one of the other machines. So it's still redundant, but it's not infinitely scalable. However, we haven't really found any customers being able to hit this limit, even with like clusters with thousands and thousands of machines. So I don't think that's much of a problem right now. One of the other things that we have is TiFlash. TiFlash stores a copy of the data in a columnar format. So this columnar format allows you to do analytical queries. And one of the good things about this is that it receives all the data asynchronously, but because of all the timestamps of the transactions, etc., the logic of TiDB is so that it can actually verify that the data has been updated and only use it if it has been updated. So the optimizer can actually choose to use TiFlash or to use TiKV based on whatever thing is most optimal, and still have consistent data for this transaction. So it's not that you get outdated data if it's using TiFlash or anything. This is written in C++ because more different programming languages, but it actually works also quite well for this project. Yeah, I think that already. Yeah.
Stop. I'm just wondering, how is then determined if a kind of query, a kind of workload has more an analytical versus transactional character, so that is decided to which backend it goes?
So, two parts of that. The first thing is that it's not based on a workload, it's not even based on a single query, it's based on parts of a query. So if a query is hitting like 2 tables, it might use TiKV for the first table and TiFlash for the second table. So it can actually combine things, which is kind of powerful because with TiFlash you can have like only a copy in TiFlash for like a few tables and not for all the tables. So that really helps. And it's up to the optimizer to make the best choice. If it's just expecting to get more rows from like many rows but only one column, it might go to TiFlash. If it has just a few rows and maybe multiple columns, then it should go to TiKV. Optimizers are never perfect. We have optimizer hints which allow you to either force TiFlash to be used or just tell it that it's not allowed to use TiFlash. That's also in case where you maybe want to reserve TiFlash for your reporting workloads and not for your main website, for example.
Yes, thanks.
So some of the other parts of the cluster, BR, we of course want to make backups. So what we've done basically is to say like, well, we want to write backups to like S3 or S3-like storage or any other shared storage. And you just trigger the backup, and then every TiKV node starts to write its own backup to this external storage. And then to restore, it's basically the reverse. The benefit of this is that if you scale up your cluster to more machines, there are also more machines writing the backup. So both making the backup and doing the restore are faster. So that's a very good feature. One of the questions I often get is that like, okay, if every TiKV is writing its own backup, then like they're all like different times, right? Well, this is also where the whole LSM tree comes in. You just set it to like a longer time span to just not delete data. And you set like whatever level is available for all. And then you have your consistent backup. So that really helps there. TiCDC, we have the option of actually sending a change data capture and send data to Kafka, MySQL, or another TiDB cluster if you want. And basically it connects to TiKV, monitors for changes, and writes it back to the target. This, of course, just like all the other components, are high available, so there might be multiple instances. We have a similar thing for migrating data. So it reads data from MySQL. It reads the initial copy and then starts to tail the binary logs to apply any changes, which is really useful for migrations. And then we have a very interesting thing in the planning for a new kind of storage engine, where basically we are just taking TiKV, but giving it access to S3. So the TiKV machines become basically a cache for reading data, Writes are first going to TiKV and then to S3 eventually in the lower levels of the whole LSM tree. And one of the benefits of doing it like this is that you can just add more machines because you don't have to copy more data, because all the data is stored on S3. So if you want to scale up your cluster or scale down your cluster, it's really fast because you don't have to move all the data. Because now, if you want to add 100 machines, then you add those 100 machines and it needs to copy and distribute all the data throughout the cluster. And with this, it doesn't have to do all of this. This sounds really easy, but there's a lot of details that needs to be right for the performance to be good.
So it seems that adding new nodes, the placement driver is going to take care of that. So I understand that. What if I'm bringing a second data center or third data center online? I want a replica of the entire cluster. What's the story there for replicating between data centers?
So if you have two TiDB clusters with replication in between, that's what we use. One of the use cases of TiCDC.
What about provisioning, though, if it starts empty?
So then you just take a backup and you restore the backup and then you start
okay, thank you.
The replication. It doesn't do the initial copy for you, if that's what you're asking for. Yeah. All right, that was all the slides I had for today. I think we have three minutes left. Any questions?
Any more, I would say.
Thank you.
Oh, we have one question here.
Yeah, you described it as a really interesting software and reasons why it is designed this way. But database cannot be good in everything it is does. It has to. Often they have to. Prioritize performance, of consistency, of scalability. How would you describe the intended use case for this database?
Yeah, so the real use case, the main use case is just large data sets that are not too picky about the latency. I think we can do quite a good latency, but of course it's a distributed system. You have to hit multiple machines, so we're not giving the same latency as with MySQL, where you might have results coming from the buffer pool directly from memory, just from memory, put it on the wire, and you're done. We're not going to compete with that directly. And the other thing is that, if you have very small data sets, the minimum size of your cluster is then not really helpful. But yeah, then our serverless cloud option might be a better option. Yeah.
Any other questions?
How does it compare to Foundation DB from Apple?
I don't know Foundation DB well enough. I think that doesn't do SQL, right? I think that only does key value. I think there have been questions for us to try and use Foundation DB as a storage instead of TiKV, but that never really matured. Yeah.
So this is better. Yeah.
Well, when mentioning names of competing products that are commercial, actually, how does this relate to, for instance, Teradata or IBM data DB2 data warehouse? They also have a shared nothing architecture, doing multiple parallel processing. Mm-hmm. So this sounds like a very interesting open source alternative for that. Is that also one of the intentions?
Yes, that's one of the intentions, and everything I showed today is all open source. Mm-hmm. So I think that's one of the great benefits that we have. This also allows you to run it on cloud, on anywhere. It doesn't require special hardware or anything like that. So that's a big benefit, I think. Open source really helps.
Great.
And so like some of the other alternatives are like Yugabyte and CockroachDB. Those are like Yugabyte is open source, CockroachDB is not, but those do the Postgres protocol and syntax. We decided to do MySQL because of like MySQL used to be used a lot in like all the high scale environments like Facebook, Google, Booking, everything does MySQL. So that's why we chose MySQL. Yeah.
And Daniel, thank you very much. Very interesting presentation. Small gift from the organization.
Thank you.
En dan is nu tijd voor de borrel.
Lijkt me ook wel een mooi alternatief op spannen.